Hey man, how's it going? Hope you guys are having a good new year. For me, it's been very uneventful, and that's a good thing because I've been on call. I just got off call yesterday morning. So this is my chance to relax and not have to worry about getting called every second. It's good times. I'm going to give it just a couple minutes. I told everybody it was going to be 8. It's going to be an interesting video because I was asked a few things by a couple different people, and I thought, let's just get it all done in one video and see how it goes. There's a gentleman from Ethiopia who asked me about repairing medical power supplies, and I said, sure, let's do it. And hopefully with a live stream like this, maybe I can answer his questions. So I hope he tunes in or at least catches this video after the fact. And if I fall over all of a sudden, it's because I'm on a riser platform that was built at the very last minute. And I'm sitting on a Dremel box on top of a chair, on top of a platform, on top of a whole bunch of ammo cans. So, like, if I fall all of a sudden, don't worry, I'll probably be all right. Let me get some tools ready. Too much eggnog. Oh my gosh, I had no chance to party whatsoever. Not only because of this whole COVID thing and the fact that I think it's going to get really bad for us all. People were absolutely reckless. I seen families in my neighborhood that were getting together, and there must have been 20 people at a house, and this happened all over my neighborhoods. So it was absolutely insane, the amount of people that were getting together. And I get it. Everybody's been penned up all year. I've been too. I haven't been out doing very much. But we'll see. We'll see in the next couple of weeks as COVID probably is going to spike. Well, that's interesting. I don't know if you guys just seen what happened. I took off the RF cage thinking, all right, I'm good. Underneath is, you can't see anything anyway because it's all just massive heat sink. Just folded over heat sink. It's whatever. Now, do you guys have any particular questions about power supplies or anything? I have some excellent examples here. A lot of my coworkers thought I was a little bit crazy because I was going through everybody's stockpile of old parts. I was ripping apart some old displays and stuff because I knew what type of examples I wanted to show for you guys. And I think I got a little bit of everything. So this is going to be good. Oh, man. On the button. All right, guys. Welcome back. First show of the new year. And this is going to be exciting because I'm hoping to do bigger and better productions for you guys. I've got so much stuff that I wanted to film and I want to discuss. And in the years prior, I just either wasn't capable of, or maybe I wasn't comfortable enough talking about some of this stuff. So it's going to be a good year. I hope to see a lot of you guys also starting to create content. So I know of one person I found today. His YouTube channel is called Mr. Biomed. and I believe he's from India. And he doesn't do a lot of talking in his videos. He just shows like breakdowns and component replacement. But I have to give it to him, man. He's got some interesting videos. I watched about half his videos today, and he's got some interesting editing techniques and stuff. I like studying that kind of stuff on other people's videos. But for me, if you haven't noticed, I just like it. I just like it raw, man. I like as minimal editing as possible. Not just because it saves me time, but if I make a mistake, I make a mistake. You know, there's only so much I can do, man. But so I've got just so much stuff that I want to cover in all these different videos that if I spent half my time editing, it would just be crazy. I'd get you guys a quarter of the amount of videos that I can kick out. So it is what it is, man. But anyway, I have some really cool stuff here that I want to show you guys. I've got all sorts of different power supplies, and I'm going to change the camera angle in just a moment so that you guys can see exactly what I'm talking about, because I have some excellent examples here of stuff that you guys are guaranteed to see. So since these are all different formats, different variants of power supplies, I'll talk about that in a moment. We'll go over all the little details and how you can troubleshoot power supplies, like particularly this one right here that I'm about to zoom in on, because some of them are repairable, you know, and other ones, you know, especially if you guys are viewing this from in the United States, you guys know that everybody frowns on repairing power supplies in the United States, and I get it. I get it because we have the logistics support, we have the budgets to support total replacement, and you know, if you had got a power supply that's gotten pretty hot and it's got some wear and tear on it, some years, you know, for reliability reasons alone, we generally want to just replace OEM components. That's just the way it is in this country. I get that some of you guys, like Mr. Biomed, you guys have to do what you got to do to keep your stuff up and going, and I completely respect that. And that's one of the reasons I started this channel in the first place, is because I recognize that there are a lot of places out there that can't get parts for your equipment. And if anything, like this year, we're in the middle of a pandemic. Our supply chain, the entire supply chain was interrupted this year. And I don't know about you guys, but they were definitely putting some pressure on me to get some of my items back up and going. And it's a good thing I know some of these tips and tricks, because there was a while there where we weren't getting parts for like a couple months this year. And, you know, you got to keep the stuff going. So there's a give and take. But anyway, I'm going to change the camera angle. And hey, man, Abdullah, how's it going, man? Thanks for tuning in. I'm gonna be going over power supplies and different types, not just medical grade power supplies. We're going to discuss some of the differences between a medical grade power supply and a generic power supply. And we're going to do that right now. So I've got a few people tuned in. Thank you all for tuning in. Some people might think that this is going to be some rather boring content. We're talking about power supplies and electronics. But if you guys are nerds like I am, you appreciate your craft and you want to learn as much as you can about it. And plus, we just nerd out on this kind of stuff. When I see somebody tearing something apart, I'll tune in. And my wife just doesn't get it. Some people don't get it. You're sitting there watching somebody tear the guts out of something, and I love it, man. It's kind of like I'll watch videos on CNCs and how they're doing different milling techniques to craft a component. I nerd out on that stuff too, but it is what it is. Hey, Jay, where are you at in Texas, Jay? I'm in Houston, man. Sitting here in Houston. I hope you're not in Houston. Oh, man, someday I'm going to make a video about Houston and what it's like being a biomed here. There is no bigger medical epicenter than here in Houston. Fact. Texas Medical Center, right here where I work, is the biggest conglomerate of medical campus anywhere in the world. It's just massive. It is massive. It is like a little city. In fact, it is like a city. I mean, they have everything from their own hotels. They have their own restaurants. They have their own infrastructure. There's banks, credit unions, all sorts of stuff inside these hospitals because the hospitals are so huge. Austin. Oh, man. I respect that. I would love to move to Austin, probably San Antonio. I think future-proofing myself, I'd like to go to San Antonio because someday I really have this dream of eventually teaching at the Biomed school, the DoD Biomed school. But I can't do that right now. I can't because I'm here in Houston, and that's a long drive, man. But it is what it is. You know, right now I'm perfecting my craft, and someday I believe I'll be good enough to teach at the DoD Biomed Academy. But Austin, I hear it's beautiful over there, man. More power to you. I've looked at some jobs over by Austin, and it's just the cost of living was so ridiculous. And not that it's getting very much better here in Houston, because you have to live far away from downtown Houston. I live in Katy, and Katy is a beautiful place. It is beautiful, absolutely gorgeous. In my opinion, it's the best place in Houston, hands down. But let me change the camera angle so I can show you guys what I got going on right here, because this poor guy, everybody looked at me like I was crazy because I was tearing this guy all up. So unfortunately, you guys are going to have to not see my pretty face. Not like it matters. Oh my gosh, what an excellent camera angle. Look at this. If you guys don't know, this is just a display. It's just a monitor. It's no different than the computer monitors you have or the TV that you have in your living room. And I chose this particular one because it's got the 3 different boards that you're going to see in a majority of TVs and stuff. And we're going to start off with this guy right here. This is the power supply. And if you think this power supply looks pretty plain Jane to even this little guy right here, you would be right. It is extremely plain Jane. And these type of power supplies right here go bad all the time. And it's not for the reason you would think. It's not because of power shock or anything like that, lightning, yada, yada. No, as things go on, these guys go bad because of these output capacitors right here. In fact, I have one right here. Let's see if I can get the angle. See this little guy right here? No, I would have to get really zoomed up and at a really crazy angles for you to see it, but it's bulging. It's kind of like this. In fact, hold on. I have in my little drawer of misfits here, I have a perfect example. Now see this guy right here? This actually came out of a power supply just like this. And I kept it because it's such a perfect example of what to look for. Now, if you see the dome, it's got a cross across it. That is your relief point. And you see that it's got a little bit of leakage right there. Hey, do you mind? Lay down. Thank you. So rude these days. You guys. So you can see that it's got an X across it. And unfortunately, I think there's too much lighting here. It's got too much glare. But there's a little dark splotch right there in the hatch. And that splotch indicates that there's a little bit of leakage going on. And that is the first indicator that this power supply is starting to go bad, because electricity works based on path of least resistance. And when one component starts going bad, generally they'll increase their resistance, so the current will go to the next component, and it's kind of like the domino effect. So the problem is if there's 2 capacitors and they're in parallel, then you will have one of them that goes bad. It makes a lot of the current go through the other one, and it'll eventually go bad too. These output capacitors right here, I know it's going to be, let's see if I can turn this a little bit so you can see it a little better. Okay, there we go. And the little guy in question is this one right here. You can see that it's maybe domed out a little bit right there. So you're also going to see that you have a large filtering capacitor right up here. These guys, the large ones, almost never go bad. It's always the little ones. And these things are so infamous for going bad on your TVs, on your computer monitors, etc., that they actually sell capacitor kits for almost every model TV that you can think of. That's right. You can type in your model, type in the words capacitor kit or repair kit, and you will find a pre-designated group of electrolytic capacitors that are already set aside in a kit. And all you got to do is desolder them and solder in your new ones, minding the polarity. All electrolytic capacitors have, you can see right here, it's got the minus indicated right here for this pin. This one here is obviously the positive. You have to mind the polarity when you're putting them back in, but it's completely fixable. So this, I wanted to break this one out because this is such a perfect example of a lot of TVs, a lot of computer monitors, etc., that are going bad. The reason it's a perfect example is because of the age of the power supply, and you can see one of them going bad, but also we've got this guy over here. Now, all of these little guys right here are step-up transformers. The reason we have high voltage step-up transformers over here is because this is a edge-lit fluorescent tube display. This is not the new fangled LED backlit displays. This is edge-lit, and this is what a vast majority of your TVs and a vast majority of your computer monitors are. All right. So instead of using LEDs along the edge, there's a tiny, tiny little thin tube here and usually up here. And what it does is there's a, they call it a gradient, which is like a film, or it's a plastic layer that's on the other side, and the light will shine through it and it disperses the light equally across the entire display. So you only have a light here and a light here at the top, and this board is the driver for it. All right. So this is called the high voltage board or the high voltage step-up board, but this is for the edge-lit fluorescent tube lighting. This one in the middle, this is your image processing board. Okay. Now, one of the things I want you guys to know is that a lot of these displays here, they have these boards marked really well. They'll usually have your voltages like indicated, written right on the PCB, so you can test it. And when you have capacitors like these that are going bad, what will happen is you will have, let's say, 2.6 volts on one wire. All right, let's say this guy right here is 2.6 volts. Because I have this bad capacitor, it might be sitting at 2.3 volts. All right, because it'll kill the voltage a little bit. And now it's 2.3 volts, which is not enough for this board to do what it's got to do. It's looking for 2.6, you know, and you would think 0.3 of a volt is nothing. It shouldn't matter. It does matter when you're talking about computer chips. Okay. So that's basically what's going on with this guy. It's 3 boards, and this is pretty much a very, very large majority of your TVs, computer monitors, all sorts of stuff, man, is going to use these 3 boards: high voltage board, your video processing board, and your main power supply. So that's how they all work together. You can see, what else could I tell you about this? There's multiple power rails on this power supply, and you could see that not only by the types of filter capacitors, but you can usually check your rectifying diodes over here, and that will kind of give you a hint as to what you should be expecting on this board. That's some pretty advanced stuff. Usually you can just look this board up online and you'll see what output you're expecting. But anyway, I got nothing else to go on for this guy because this one is not what we're here about. All right. It was just a perfect example of what I wanted to talk about. Now this mat, this is actually working out quite well for this. Let's see if I can get this camera to focus. Focus, focus. There we go. All right. Let me get a couple good examples of some other power supplies out here for you. Oh my gosh. Let's see. I'm going to continue with my course in biomedical. My question is, no one wants to hire a person without experience, and I'm on 40 years. What do you think? Do I have any possibilities? Yes, you do. You absolutely do. and I've talked about this in several videos, is that, to be honest, you don't even need a degree in biomed to be a biomed, okay? It just depends on how willing you're hard to work, your trainability, and your work ethic. I mean, that's really it. And part of your work ethic starts with trying to get hired, okay? You have to put in the work, man. If you carry a degree, it's going to be easy for you, easier. But if you don't have a degree and all you have is experience, like me, you have to put in the work, which means study up on extra stuff that they hopefully would have taught you in school or whatever. But I'm telling you right now, there are so many companies that do medical equipment, either directly, indirectly, whatever. There are so many opportunities for people that work in medical equipment in so many cities right now. Bjorn, it's about time, man. I was about to write you and tell you where you at, man. I see you over there. Let me adjust the camera because I need to. Thanks for joining, Bjorn. So, guys, take my word for it, man. If you start a job with an OEM or with a third party that sells used medical equipment or something along those lines, you can get a job without even having a degree in biomedical. It is possible. You have to put in the work, and that work means your professional development too. It means you go home, you study up on some stuff, and know what the hell you're talking about. Okay, so if you're going to apply for a company that does medical lights, study up on all the major vendors of medical lights, and study up on previous generations and technologies of surgical lights or stuff. You have to put in the work. So yes, you can get the job. Okay, don't give up, and if anything, contact people in the community. All right, every city has got like a biomed group. Contact them and just introduce yourself and ask about job possibilities. Man, there's so many ways I could go with this, because I think there's this consensus out there where biomed is such an impossible field to get into, and it's true that I got in because of the military. So maybe you might want to call that the easy street way of getting in, even though it wasn't easy. All I can say, man, is put in the work. And I've talked to other people about biomed. I've gotten other people into biomed, and people that have had no technical degree, people that have never worked on medical equipment before. They were just willing to put in the effort and work on themselves. Okay. Oh man, 3 a.m. Bjorn, 3 a.m. Oh, you're killing me, brother. Oh my gosh. Well, you are Mr. Motivated. Good on you. I hope you get to sleep in, brother, because I was going to do this video later, and the gentleman from Ethiopia asked me to do this at 10 p.m. But according to the history of these live streams, I seem to do this for like 2 to 3 hours. So if you can imagine, that would be me getting out of here at like 1 a.m. And I would probably be dragging ass by then. I would be just murmuring by the end of that video. So guys, thank you all for tuning in. I understand that it's early for some of you guys. I'm experimenting on when I should be doing these type of videos. So Bjorn, you were asking me about power supplies as well, only yours were for ionophoresis, I think. So power supplies are power supplies. The only thing that's going to be different is your final stages and whether it steps it up, steps it down, and whatnot. But I'm going to show you guys a few other things about these power supplies that are going to get you a little bit closer to figuring out what's going on with them. And I'm going to do that right about now. Oh, this camera is so hard to move. All right, I hope this angle works for you guys. I'll try and get you some close-ups and everything. I have some excellent examples of power supplies here. And this guy here, I took the shroud off, and I was quite disappointed when I did that because it didn't do nothing for me. There we go. So this, let's first talk about medical grade power supplies and what they are. Okay, so these two here, especially this one, is a medical grade or industrial grade power supply. And there's a few reasons why you could say that. This one here is definitely better. One of the reasons being, as you can see, it's got some shielding over some of the output stages, which is where a lot of your noise comes from. Noise and feedback are the biggest differences between a medical grade power supply and a not medical grade power supply. It has nothing to do with reliability because all power supplies suck, but it has more so to do with feedback circuitry, adjustability, and more specifically noise. And this right here is an RF cage. It's also, you know, to help protect, but it's you enshroud the power supply to help minimize noise, which is one of the reasons we have this bad boy right here, is to help minimize noise. I don't think they have this heat sinking anything up here. All the heat sinking is done along the sides. Yep, you can see all your hold down fasteners right there, and a couple of them over here. And some of the tabs are right back there. But medical grade power supplies are shielded. They have extra noise reduction, and you will see redundancy, especially, see if you can see right down there. So you see those two brown round things? Let's see if I can get you a better pointer. Okay, you see these two things right here? It's this one and this one. Those are fuses. Now, there's two of them in there, all right? And then you take a look at a non-medical grade power supply like this one right here. And let's see, what does this guy have? I'll be damned, is this a medical grade too? I don't think so. This one's missing a lot of filter output. Where's my other one? Anyway, one of the biggest differences between medical grade and non-medical grade is that you're going to have the line and the neutral, which is your 120, 240 volts, and your neutral, both of them fused. Okay, and that's a pretty big thing because on most power supplies, you will only have a single fuse. Now this one here is a pretty good example of that. See, I got one fuse right here. See that guy? And this one is obviously rated differently. It's got the cage on it, but notice how it's got other things in redundancy. You got capacitors here. You've got some input filters like these ones right here. You can see how they are line and neutral. Both of them are, these are isolating transformers. Just like up and under here. You can barely, let's see, you can barely see them. See this coil right here and this one right here? So when power comes into your power supply, one of the first things it does is it goes into a filter. So you'll have a capacitor and you will have a thermal resistor, and you're going to have an isolating transformer, all right? And it's just an inductor. So basically, you're going to filter the noise that the power supply generates, and you don't want it coming back out into your line power, okay? So that's not necessarily to protect the power coming in and to clean it, but it's also largely to protect the noise that these switch mode power supplies are making and to keep it from going back up the line, okay? Because you got other medical devices, you don't want that noisy ass electrical going back in and affecting other devices. So that is one of the biggest difference between medical grade power supplies and not medical grade. Now this one here is obviously a stripped down version, but this does have some redundancy on some of the stuff and not on others. Like I do have two fuses here. I'm really blown away by that because it's only got a single filtering capacitor, one single inductive coil, and let's just take a walk through a power supply so that you guys can see what what exactly is going on with these bad boys. And I think the best way to do that is to pull up this display again, because that is such a cool power supply. Oh yeah, that's a big girl right there. All right, let's pull this guy out. I'm just gonna pull the power supply completely off. This display, if you can't tell, is already spoiled. I'm never gonna put this back in its plastic cage. This was from an MRI room that was being tore apart, and I just nabbed it. It was sitting in the pile, and I ripped the components off of it, stripped it down, and here we are. Oh man, always get the correct Phillips, all right? I got a number 1 Phillips, and I should be using a number 2. Oh. All right, here we go. I'm digging this mat. Even though I'm never going to put this guy back together, I'm still a repairer and not a breaker. So I feel really bad when I scratch the face of monitors, even though I'm never going to ever use it again. So that's why I got it on my silicone mat here, and I'm digging it. Also got all these spaces to put fasteners as you pull something apart. I'll tell you what, man, I started using one of these at work, and I love it. There we go. Okay. There. Let's get rid of this guy. All right. And the reason I'm using this one is because it's a perfect example of what a medical grade power supply is not. All right. So you can see we have our AC input, your IEC AC input module right here, and it's got a soldered on ground that goes immediately to your chassis. This is interesting. They have a built-in power switch right on the PCB itself. That's pretty cool. As I said earlier, one fuse, and you have one coil, one capacitor. You see the trend here. It's just 1, 1, 1 because, you know, cost of construction, you don't want to waste components if you don't need to. TVs and monitors and stuff, they're trying to sell them for as cheap as possible. So they tend to try and cheap out on componentry. So your power is going to come in through here. Obviously, one of the first things it's going to go to is your power switch. And then from there, well, it's going to go through your fuse to the power switch. And then it's going to come over here, and we have a bridge rectifier. Now, all of these power supplies have a bridge rectifier. Some of them, some of the cheaper ones will have 4 separate diodes, and they act as bridge rectifier. But anyway, these ones all have a bridge rectifier on them, and this one is nice and obtainable. It's right on the outside. Some of them, it's an absolute pain to get at. Let's see, where's it? Yeah, you can see it on this guy. It's right here on this tab, which I guess is kind of cool, but a nightmare to get to. So these TV power supplies are very repairable. As I said, oh, I wonder if I can show you guys that capacitor that was leaking. Yeah, it's that one. It's bulged a little bit. I don't think the camera's going to pick it up. Anyway, so what happens is the power comes in. It goes through your switches and your fuses. It is also going to go through your filter components, and then it comes over here to your bridge rectifier. And your middle 2 pins have a wavy line on them. I don't know if I can get that in frame. So your middle 2 pins right here have a little wavy line, and then you see the other one's got a plus. This one over here has got a minus. So that is going to be your DC bus, okay? And that is a, I guess you could call it a high voltage DC bus. You have to be very careful because you'll arc the shit out of something if you do it wrong from this point on, okay? So up till here, everything is AC. when you switch over right here, it's going to be DC, okay? And the reason that's important is because when you are doing troubleshooting with something like an oscilloscope, you have to make sure that both your coupling is correct, and more importantly, you have to be really, really careful of what you're measuring if you're grounding incorrectly. Because when you're doing like AC checks, with power supply, when I'm doing AC checks, I use this guy. I've showed it in a couple other videos. This is a Fluke AC field detector. So you can literally, while this thing's on, you can just move it around and you will see it light up when it's near a component that's got AC power running through it. It does not work for DC, okay? Just for AC. So anyway, the power is going to go through your bridge rectifier. And with me here in the United States, we have 120 volts coming in, and you're going to get like, what, 80, 90 volts DC on this guy right here. And 80 to 90 volts DC is nothing to joke around about. That's some serious stuff. And then what it's going to do is it's going to go into a, let's see if I can show it on the bottom. It's going to go into a MOSFET, okay? And it's going to be your main switch. And most of these guys right here, it's going to be a MOSFET that looks very much like this, okay? It's going to be a larger one. And on the back, you can see it's got the metal tab. It's going to heat sink to another component like that. And what happens is over time, the heat sink will eventually dry out, the little paste or whatever they use. And sometimes this guy will just run hotter because some of these other components will start going bad. This guy right here is a big, big problem with so many power supplies, and I will show you why. Let's see. Should I do it with expensive meter or cheap meter? Let's do it with the cheap one, all right? I'll take this Klein. And in my other video, I showed you guys that we do a lot of stuff in ohms or continuity mode. I will do it with continuity because it's quick and easy. I don't have to see my meter. I can just throw it off to the side. Now, inside this guy is basically 4 diodes. And the important thing about that is diodes like to fail in a short, okay? They never, well, I shouldn't say they never, but they almost never blow open. They fail in a short. And if you guys know about diodes, electricity will go in one way and not the other, okay? So one way it's forward biased, the other way it's reverse biased. So technically this guy here should not be shorted, but watch this. This whole entire component is shorted. Now, what I could do is reverse my leads, because what happens is in order to test for resistance, ohms, or even continuity, there's actually voltage that goes out one probe and goes in the other probe. So when it shows black and red on your probes, that's for a reason. It's not just because people are anal retentive. You should put your red lead on your red connector because voltage does have a polarity when you're doing ohms measurements, all right? So it does matter what direction your leads go, because you could be forward biasing a diode and showing a short when in fact, you know, it's shorted out anyway. So always reverse your leads when you get a positive finding like that. Reverse them, okay, just to check, just to be sure. So that is a MOSFET, and you can see it's shorted, it's garbage. Right here I have a rectifying diode, and this is another troublemaker. You can see rectifying diodes, let's see, where are you? They're often down here. I'll show you maybe on another power supply. Yeah, these are diode matrices down here. But anyway, this guy is the same thing. It's a diode. So you can tell this guy right here is shorted just the same. And I keep a whole list of these things floating around, even some tiny ones. These guys here came out of Belmont Rapid Infuser, and this is the one of the MOSFETs that controls the battery charging circuit, shorted just the same. So normally they fail in a short, and when that happens, you will get a burnt fuse. Okay, you will almost never get a burnt fuse from just hooking up a power line or from turning it on and off. Some people like to say that there's a voltage spike or whatever, and that's what caused this guy right here. There are components in a normal power supply that are meant to limit inrush current. So do not think that your fuse blew just for natural causes. It's almost never for natural causes. There's something that caused it. So what I generally do, let's see if you guys can see this. Now this one's probably a good, yeah, see, it's probably good. But if it beepity beeped like the other ones did, then it would be shorted, and I would desolder it. And when you desolder it, then you check the component out of the circuit as well, because I have had this where the component that you checked, it shows that it's shorted, you remove it, sure as shit, the unit is not shorted anymore. So it's something further up. It's rare, but it does happen, okay? So always check your component after you desolder it. Anyway, let's get back to it. Your AC comes in, goes to your DC bus through your bridge rectifier. Now you're working with DC. It comes over to your main switching MOSFET, okay? And your main switching MOSFET is the guy that turns this guy on and off really fast. Let's see, I got other ones I can show you. Okay, here's your AC comes in, filtering. Oh man. This one's got little arrows and stuff. I wish I could get images of it. This is a cool power supply. But this one here has redundancy built in, and this is probably a really bad example to show people. But anyway, the whole reason that these power supplies can be so tiny, like this one here, this guy here can handle some wattage, some serious wattage. The reason they can do that is because it's a switch mode power supply. And it's a switch mode because you have this guy right here switching the voltage on and off at an extremely high frequency. Okay, so you got DC, which is, you know, what, 70, 80 volts, maybe 90 volts DC. And it comes over to this guy and it turns it on and off at what, kilohertz, 2 kilohertz, 50 kilohertz. I don't know. It probably depends on the power supply. But it switches it on and off an extremely fast frequency, which is why your transformer can be extremely small, because the higher the frequency, the smaller the transformer for the same amount of wattage. And line power is 60 hertz. So if you ever pick up like your stereo in your living room and you notice this damn thing is really heavy, it's heavy because you have a huge transformer in there. And you have to have a huge transformer because these guys are noisy. You remember when I said it's noisy? If I were to put a Bluetooth speaker next to this guy and play some music while this guy's powered up, you'd probably hear some staticky, fuzzy stuff going on, because these things create noise, which is why we have the Faraday cage, the RF cage. You know, it's to help limit some of that from getting out. So it switches this guy on and off at a crazy high rate. And then from there, it goes back into a rectifying diode, which on this guy, well, you can see some of my bus going up the side. So it's going to come over here, probably to this one. Yep, Q2. So that's why it's on this bar over here. So it's going to throw that AC, because it's a high frequency AC. It's going to come up here to a rectifying diode. And then from there, it's going to go to other places. I almost never have a problem down here, okay? Almost never, except for these capacitors. These guys are trouble. It's almost always your power MOSFETs are your power transistors, almost always. And if you can tell, like I've got a collection of them here because it happens so often. And this is just the ones I wanted to save. 50 kilohertz minimum. Yeah, it's extremely high. I know that for a fact. And you know, compared to 60 hertz, and 60 hertz, we throw it through an iron core transformer, and the iron core transformer has a lot of hysteresis. And this guy here has ferrite, all right? And ferrite is like it's a synthetic component, and it has an extremely low hysteresis. So you can flick this guy on and off extremely fast, and it doesn't want to hold the charge. So that's basically what I'm saying, is the old ones have a transformer that's huge. It's made out of iron, and that's why they're so heavy, like the ones in your stereo. And the reason you use that type of transformer in your home stereo is because it doesn't create noise. And all you guys that are audiophiles out there, you know, like your Class A amps and stuff, you would never find, never find a switch mode transformer in a nice piece of audio equipment, because they do generate noise. No matter how good it's built, it's going to create noise because of what it does. This is an excellent little example. We have the AC that comes in. My bridge rectifier is right here on this heatsink tab, and I got stuff falling out of it. Spare parts. So this one right here is my bridge rectifier, and then it comes in, and on the back side of this, you're never going to see it. Right here is going to be, this is my switching MOSFET, and it's always next to your main transformer. And from your transformer, it comes on over to here. And over here, you're going to have a rectifying diode, and it's going to break it back down to your DC. And then it's going to go through step up, step down transformers, like right here. And that's going to give you your final output. So actually, this guy right here is a T2. So if you guys notice, they'll often have your transformers listed as like T1, T2, stuff like that. This one right here has T1 written. So all the time on your boards, there's going to be, for especially electronics like this display, there's a standby power transformer. And your standby power, there's a tiny little bit of voltage that's going to come in to this guy right here, and it's completely separate from this guy. And what this guy does is it has a little bit of power that goes up to your power button. You guys have all hit your power button on your front of your TV, and there's this little amber light, and that goes green when it powers on. That's this guy. So what it does is it throws the voltage out to the power button. When you press the power button, it sends the signal all the way back on these ones right here. We'll talk about that in a minute. That's your standby return, and it comes back and it tells this guy via this one, this little chip, it tells it to latch on, and it activates all this garbage over here. Okay? But anyway, I don't mean to get in that much detail. What you guys really have to know is that your bridge rectifier almost never goes bad. It's extremely rare. If you pop a fuse, it's probably because you have either a transformer that's shorted, or you have a power MOSFET that is going bad. And the way that you test them, you put your meter on continuity, you check it, and if you show that it's shorted, pull it out of the board and check it outside the board. Make sure you flip your leads around because of the polarity of the electricity coming out of your probes, and then you're going to test your component. Oh my gosh. Let's see, I haven't been paying attention to the chat over here. I'm so sorry, you guys. Oh my gosh. Well, thanks, man. I like that you like my mat. I appreciate that. They use a toroid transformer. You are absolutely right. And in fact, I have some toroid transformers over here in my CNC machine, because that's another area when you want electronics that are designed for precision. you want there to be a very clean electrical signal powering those boards, because if you get noise, then things like your servos, especially if they're cheaper servos, they can recognize noise as a pulse or as an error and give you all sorts of problems. So you want a very clean transformer. Oh, hold on. Hold the phone. I have the perfect example. Just one second. I got this big girl over here I'm gonna pull off. Yeah, that's what I'm talking about. All right. Okay. All right, as I was talking about your transformers and ones that are designed for clean power and no noise, this is a toroid transformer, okay? So this guy here has an iron core, and this particular one is an isolation transformer, and it's a real isolation transformer. I pulled this out of the bottom of a audio video cart, I think, and I finished wiring it up because it's got a 1-to-1 on the primaries and secondaries, which a lot of transformers don't have that. So what I did is I wired 2 of the outputs in parallel, and I got my primaries, and that gives me more current if I need to. And I have them plugged into this wonderful guy, and this is an isolation transformer, which basically means that I can plug this guy into the wall. If I'm testing something like this power supply, I would plug the AC into this guy instead of into the wall, because when I'm working here, especially on the silicone mat, I hopefully will not get shocked. All right. The problem is that if I work with wall power to here and I goof up, or let's say that this guy is shorted, which I have had before, that was not fun. I had a power supply almost identical to this one right here, and this damn thing shocked the hell out of me several times, because I could not believe that I got shocked from touching the heatsink. But that heatsink was hot, and not temperature hot. I mean, it's electrically hot. And it just happened because there was a short in the one of the power MOSFETs, and it shorted to that metal backplate that I referenced earlier. See how it's got this metal backplate? Well, that shorted to line power, and I got lit several times when I touched it. And so that's why I keep this isolation transformer around. If you guys have a chance of making one of these isolation transformers, or if you find one for sale someplace, do me a favor and check when you get one of these isolation transformers, because some of them say they're an isolation transformer and it's just a noise isolation transformer. And there is a way to test that, okay? On a true isolation transformer, you should have 60 volts on your neutral and on your hot, and combined from wave to wave, that makes 120 volts, okay? Mind you guys, I'm in America, so it's 120. On an isolation transformer, it on your secondary side, if you haven't seen my video on it, please go back and look for it. It's a whole video on isolated power. It'll answer your questions on what I'm talking about. I'm going to explain it as best to you as I can. But what this guy does is it dereferences what I'm working on to ground, okay? When you're touching an electrical device, you are at ground potential, okay? And on your electrical, you have ground, okay? And you have neutral, and then you have 120 volts hot. Ground and neutral are technically the same. Now, you guys don't blow me up in the comments. Oh, no, they're not. They're just get off it. They're technically the same, okay? Ground is not normally an electrical carrying conductor. It's just there as a backup. It's as a safety, but they're technically at the same potential. So you, as the technician, are also at that potential, because like me, you're probably touching something, you are at ground potential, okay? So as I'm working with this stuff, I can get zapped. Now, if I plug this guy in, ooh, that was a sexy little hum. I don't think the camera picked that up, but that was nice. I appreciate that. So as I go, you can see right there. Whoa, is that really backwards? That is so crazy. I'll fix that some other time, man. So you can see that the windings on this particular transformer are not exactly 1-to-1. It's like 1.105 or something like that. But anyway, I got 128 volts on the output. Doesn't even matter. But if I go from one of my prongs to my ground, you can see it's just showing me some ghost voltage. I got like 33 volts. It's not real. Okay, it's not real. Here it's saying I got like 68 volts to ground. I got 56 volts to ground. There are some weird things that happen when you start lifting ground. Okay, so there is no ground on this guy right here. There is no ground. There's no need for ground. This ground right here is completely floating, which means it's not connected. You can see I've got the green here. All that green is going to is maybe to the case or something. Ground is not doing anything right here. And the reason we do that is because I plug this guy into this and I'm working on it. I could be touching, 120 volts, but it will not shock me, or it shouldn't. I might feel a tickle or something, but it shouldn't shock me because electricity is always trying to get back to its point of origin, all right? Its point of origin from here is ground. From here, it's L1 to L2, So if I'm not touching L1 or L2 while I'm touching something else, I'm okay. But if I lay my arm across there or something, of course, I'm probably going to get lit. This isolation transformers make your life as a technician way safer. Not too many people use them, but then again, not too many people tear into this stuff. So if you're a real bench technician, I highly suggest you get one of these because once in a while, you're going to get a unit that's going to be hot and it's going to save your ass. That's the truth. I've been electrocuted several times, and it's almost always because the equipment was faulty in some major way. So anyway, that was just fortuitous. I had my isolation transformer here. Oh, guys. Let's see. What can we do? I'm considering buying an ESR meter to take the guesswork out of checking caps. Something that might not be a bad idea, but I just replace them. They're cheap, and at work, I have some old ass electrolytic caps. I would not put those in a piece of medical equipment, but if I'm dicking around, just having fun, sure, go ahead. If it's a TV or something, yeah, of course, I'll probably use old ass capacitors, but they do have a life expectancy, all right? They are a component that is subject to leaking. You can see right there, that guy's leaking. And over time, they eventually go bad. You guys that have ever worked on like guitar amplifiers or something, you guys probably experience this all the time. Bad capacitors. Just happens, all right? Oh, let's see. DJ Programmer. Thank you for making this channel. I just graduated, and ever since I did my internship, I've been excited to get involved. You know something, DJ? You are going to love this career, man. Absolutely love it. And don't worry about the baby boomers out there and the people that are going to put you down, maybe not put the effort into training you as a technician. Don't worry about that. We all have been down that road, all right? Somebody pointed out to me just earlier this week that I am the second youngest person in my shop. I looked at him. I was like, really? The second youngest at my shop? And there's only one other person. He's like 36. I'm 40 years old. And I've been a Biomed for 18 years. I'm like, I don't want to say I'm number 2 in my shop, but I only report to the shop manager. So I guess it kind of works that way. And here I am, the second youngest in the shop. So that goes to show you, man, that don't worry about age. It's all about you and the effort you put into your own professional development stuff. And don't get agitated when people are dicks to you. Believe it or not, I've been doing this for a long time. And when I started this job, almost exactly a year ago, it was a year ago when I started with this hospital. There were several weeks there where people were talking behind my back and just being complete dicks. Like, who the hell does this guy think he is? He's got a YouTube channel. I'm dead serious. Like, I heard it all. They didn't even know that I was listening because I chose the desk that's down at the end of the workshop, and they didn't even see me when I came in the morning. And I heard a bunch of people talking shit down at the other side. And that's okay. That happens. And you just have to understand it's a competitive world, and some people think that they're going to get promoted based on tenure. Other people are going to get promoted based on their trainability, their motivation, and what you do to spoof up your resume. All right. So while they're making fun of my YouTube channel, guess what? You bet your ass it's on my resume, because I put a lot of time and effort into this. I put a lot of time and effort into myself, and I put a lot of time and effort into generating a good team. Okay, because that's what this all is really about. Is about us being able to make better technicians. So if that's me, if that's somebody else, it doesn't matter. But trust me, don't get too excitable when you get to a good hospital and you have to deal with some older technicians that are giving you a bunch of gruff. Okay, it happens to us all, and it's probably going to happen to you too. And you can touch one output wire at a time without shock. You are absolutely right, Bjorn, and that is the beauty of it. So as I was saying, like, I got lit by that one power supply because it was shorted to one of my heat sinks. But if I was using an isolated power supply, it wouldn't have been an issue. It did clue me in pretty quick on what was wrong with that power supply, though, because, stupid me picking something up while it's live, and I guess you can do the wet finger test to see what, where your electricity stops. How much did you pay for that Fluke DMM as well? Is it 287 or 289? This, man, you are very astute. This is a 289. All right. And this one here, normally a 289 is $600 or $700. You can find them for pretty good sales sometimes. And half my meters I bought off of Craigslist. This one was not one of those. This meter here I bought because it's got one super cool feature. I said it in one of my other videos. This multimeter has got a remote monitoring module, which also has Bluetooth, which means I can put the Fluke app on my phone and I can either record what it's doing. So let's say that there's an anomaly when I power on a device. It does a voltage sag or something, which means your voltage takes a dip. Voltage taking a dip means that there's a short or something going wrong with the power supply, and you use your multimeter to record that. And the Fluke's got a really cool app. I can do that, or I can set my meter up and I can safely be on the other side of the room at the breaker, and I can turn on the breaker, and if the stupid machine's starting to catch fire or something, I can see what it's doing on my phone, and I can kill the breaker really quickly. So because not everything that we work on plugs in. One of the things I had to do this to was a motor that was up inside one of my motorized booms, and that stupid motor was latched on. It was so hot. It was so hot that it was almost melting the plastic surrounding it, the shield plastic. And it's because it was driving, even though it was all the way actuated down, it was still driving it because it was latched on because of this guy. How fortuitous that we're sitting here and I've got these junky components, because I had a relay that was, the points after a period of time under load will solder together, they'll melt and they'll latch on. Normally they come open and close. Well, over a period of time, they all just tend to do this. They start soldering the points together. Relays are technically a consumable. It's just we never usually see enough load cycles on them to experience the fact that they're a consumable. Just like technically electrolytic capacitors are a consumable. It's just you know, it takes years for them to start failing, but when they start failing, you start having anomalies. You guys out there that have old computers, I dare you, open up your computer and take a look right around the processor, okay? Your processor in a computer has got a whole bunch of capacitors around it that are used for smoothing out power, because the faster you speed something up in the computer world, it needs stabler and stabler power, which is why you have all those stabilizing capacitors or filter capacitors surrounding your processor. But the problem is so many times they're just like this poor guy right here. They'll be bubbled up, leaking out, and what that does is it gives you some voltage anomalies, and those anomalies can create your blue screens of death, failure to boot, a whole bunch of problems with your PC. So if you're working on a computer at work and you just reboot it and it starts working, it's a Band-Aid fix, guys. Open that bad boy up and take a look. And if you start seeing capacitors like these, where they're leaking out the top, they're starting to bulge, replace that motherboard. Okay? Oh, let's see. What else can I see for you guys? I'm just sort of half your age and I already feel wasted too much time. Oh, wow. Man, let me tell you, I did not join the military until I was 23 years old. And although I was fixing photocopiers, faxes, industrial printers, and before that I was fixing cars, I can't exactly say I was going somewhere at the time. I was one of those people that was just working to make as much money as I could, and I was a very diligent worker, but I didn't really have a sense and purpose and direction. So it's just one of those things that, you know, I joined the military and I went into medical electronics, and here I am, man. So don't feel bad about it, because I know people that are Biomed 3s and they're in their mid 60s, okay? And they just started being a Biomed like 4 or 5 years ago, okay? So if I can get somebody that's 63, 64 years old to be a Biomed 3, and he took over my position when I left a hospital because he was such a good worker and the man knew his stuff. So I'm just saying, it's up to you. How motivated are you, and how trainable? Oh, man. Awful student. Boy, they couldn't keep me busy. You know, I would like to say that I'm a good student, but that's a lie. Okay. I learn so much on my own if I put myself to the test. All right. I am one of these weird, funky cases. Believe it or not, a lot of biomeds are right in the same boat as me. I do learn way more by putting my hands on it, but more so, I'm not really one for waiting till the last minute to get stuff done. But I know that some of you guys have been watching these videos for a while, and I've been saying, hey, I'm going to put out this video on SpO2 and Untitled CO2 monitoring, and I've started doing the work on it, and I just drag feet. And I drag feet because I have so much stuff going on. But I did it, and I did it before the end of the year. I posted it maybe 2 hours before the end of the year. But it's one of those things where I have these goals, right? And my goal was to get that video out by the end of the year, and I did, although just by a couple hours, but I still got it out. And that's the thing, I'm motivated in that way. But I was dragging feet on it, and I just set these goals for myself, and I will get it done. I will not fail. So I was there all day, given I was on call and I wasn't going anywhere, but I was working on that video very diligently. And I did that because of this channel, and because I promised you guys I was going to do something. If I say I'm going to do it, I'm going to do it. That's a promise. It's going to happen. And that's the way I am professionally. That's the way I am personally. If I say I'm going to do it, it's a promise. I am going to do it. Okay. And that goes all the way back when I was a redneck running around without shoes. Okay. If I say I'm going to do it, I bet your ass I'm going to do it. Okay. Let's see. I had to wait 13 years before not being the youngest in the shop. Oh my gosh. And how crazy is that at 40 years old, I'm still the second youngest in the shop. That's That's not good, okay? That's not future-proofing your shop. And if you guys haven't noticed, as people have been working in one hospital for a long period of time, they get complacent and they get into these habits, or they work themselves into comfort zones, and they don't want to get outside those comfort zones. So like right now, I'm working with these guys and they're excellent guys, all right? It's just that here is a 40-year-old coming in, and I'm like, guys, I got this new system, this new way of doing work orders. Let's go out, let's experiment with this. Let's go scan an entire hospital tower, and let's go see what results we can get from doing this. So I had 10 people out there with computers and the program that I wrote, and they were scanning barcodes, and we brought all that data in. We found like 109 unable to locate pieces of equipment. We found like 500 items that were not on record, or they're mislabeled or something. And we were able to pull all that data because we went out and physically found the items. But we were doing it with scanners and barcodes and spreadsheets. And these guys, some of these guys are old school. Like they're used to like printing their work orders at the beginning of the month. They get like 10 sheets of paper. They'll flip through the sheets. They'll check the item. They're like, no, that's not it. They'll go over to the next item. They'll flip through a bunch of sheets, look at it. No, that's not it. And they'll do this. They'll go around an entire department flipping sheets and looking for like 20 or 30 items. And I'm like, why the hell are we doing work orders that way? All right. Doesn't make any sense to me. I would rather have all the work orders on one spreadsheet. And when you scan an item, it comes over and it says, hey, there's a work order open on this device, or there's not. And as fast as you can scan barcodes, beep, 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 beep. It's checking to see, is it on record? It's checking to see, is there an open work order on this? Is there a recall on this device? I can do that as fast as I can scan it. And then you also have a historical record. Today, I had a vendor that called me up today, given it's a Saturday. He wanted to know about a freezer in operating room number 3. I pulled up my spreadsheet from when we did an inventory, and I looked through, and I don't see a freezer in operating room number 3, okay? And I was able to tell him that because I had the data right here on this stupid laptop, right? So it creates a historical record that you can search later if you need to. And I did today. But some of the older guys, they were a little standoffish to this new technique, even though, as biomeds, there's one thing that's absolutely certain, is they are asking us all to do more with less, okay? We're asked to do more work orders with less people, or we're asked to cover more areas with less people. It's more with less. That's the general theme of biomed everywhere, all you guys. So you all can probably relate to this. And we have to find ways of doing business better and faster, okay? So it is what it is. Let's see. That's a really cool feature. I believe it's already a graphing feature, record values over time and the study characteristics as well. Yes, you're absolutely right. But from a technician point of view, it's a lifesaver. It's literally a lifesaver. Because when you are working on mains voltage someplace, you should have somebody else working with you at all times. I leave the door open. If I am working here in my garage, you betcha I've got the door open. All right. And when I'm working at my workshop, because a lot of biomed shops, the door locks, well, I keep the door open. I prop it open with a trash can or something, and people pop their head in, whatever. But do not troubleshoot mains voltage by yourself. And one of the ways that you can do that is you set your meter up on a unit that's de-energized, and then you go and click the power on, and that way there you're not holding the meter, okay? Use jumpers. I showed you guys these jumper wires in other videos. Use jumpers, I swear. Clip these bad boys on when you're going to power something up, and then power it up. Don't be sitting there holding your meter on it, because that's how you get lit. All right. Let's see. I'm so not paying attention to these notes over here. And if I'm talking too much, guys, please let me know. I've had like 2 cups of coffee today because I was like falling asleep midday, putting away Christmas decorations and all that fun. And I was like, guys, I am not going to be able to do this live stream if I'm just dragging. So 2 cups of coffee, and here I am just rattling off like I do. So I apologize for that. True relays, electrolyte caps are pretty much consumables. What about MLCCs? Well, that's a good point. My laptop died and it has a short circuit in the VCore section. There are programs and there are ways of fixing your laptops. There's more information on fixing laptops now than there ever was before, especially if it's an Apple product, which I am not a fan of Apple products at all. Okay, but if you have an Apple product, more power to you. There's so much information online about how to fix your product. That's the good thing about carrying a product that's a standard like Apple, is they only make so many products. Whereas like Samsung phones, there's a whole bunch of them out there, right? So there is information on how to fix your laptop. Just like you, I love fixing things and learning by doing. I'm not really good at book studying. Well, so I have a very funny story for you guys. It was what was it? New Year's Eve? I think it was New Year's Eve. I just came to this sad realization that I have not been home in a decade. Okay, my home is Michigan. I'm in Houston. It's across the entire freaking country, but there's something that's been bothering me for a long time, and I need to get back home because some of the people that I know from back there are getting really old. Okay, and one of them is a teacher that I had back in school. A man other than my grandfather, two men that changed my life completely. All right. So there's this one teacher. I don't even remember what he taught, but at the very last day of the school year, he gave me a book. Okay. And he said to the whole class, go up to the library. He had this like shelf full of books. And he said, pick out a book and take it home. It's yours to keep. So I went up to the library and I was flipping through all his books and I found this really fat, old, ragged book. And it was called The Way Things Work. Okay? It's an old, raggedy book, way thick. It was full of schematics and diagrams and breakdowns of all sorts of devices. Okay? And he said, hey, Justin, what book you pick? And I showed it to him. You know, because all these other kids are going for like, you know, the kids' books like Clifford and stuff like that, you know. There a lot of them are going for kids' books or like for fiction, stuff like that. I went for this old raggedy, I guess you could call it like a repair encyclopedia. So anyway, he's like, ooh, see, I remember this to this day. It's 25 years ago, 26 years ago, something like that. It was a long time ago. And I still remember everything that happened minute by minute. He goes, I don't know, Justin. And he showed me, he flipped it open, and right inside the cover, there's an inscription from his wife. And it said, Bob, I hope this book takes you places, or something like that. And it said, love, Sheila, his wife. And he showed me that, and then he took a pause. He's reluctant, and he says, do you think you're going to get something out of this? And I said, yeah, absolutely. And he said, okay, you can take it. Well, I took that book home, and I read it cover to cover at least 6 or 7 times, maybe more. I've had it over the years. It's been in my parents' library when I moved out, when I went into the military. There that book sat. Every time I came home, I found the book on the library, made sure that it was still in my parents' house, and I'd flip it open, and every once in a while, I'd still go through that book, right? And I always intended on giving that back to him, you know, and I wanted him to know what kind of impact that this made on me. And, well, I come to the realization that he's getting older. I have no idea how old he is. He's got to be 70s at least, late 60s to 70s. And anyway, I thought I'm not going to get home with a chance to give this book back to him. So on New Year's Eve, I was at work and I'm on lunch break. I found his wife on Facebook and I thought, this is it. I'm gonna go out on a limb, and I'm gonna tell her the story of what happened, and the fact that I remember it, and I want to tell them everything that happened. Okay. I've been thinking about this moment for years, because that moment, that one book that he gave me, pretty much changed my life. All right. I love tearing stuff apart before, but understanding how it worked was the key. Okay. You can tear the hell out of something, but if you don't know what does what, tearing it apart did this much for you. All right. So anyway, let's see if I can pull it up for you. So I wrote her, and I wrote her a long thing out of the blue. I was hoping she didn't think I was a weirdo. And I wrote her and I said, about 25 years ago, your husband Bob allowed his class to each select a book from his personal collection to take at the end of the school year. I selected an old book titled The Way Things Work. When I showed Mr. Blank the book, he was reluctant to let it go, as it had an inscription inside that meant a lot to him. He asked, will you get some use from it? And I excitedly replied, yes. I've read that book many times over the years, and it's launched me on a career in medical technology. I've been a biomed equipment technician for 18 years. I run a team of technicians that manages over 70 operating rooms in a massive hospital complex in Houston. I also run a YouTube channel, Better Biomed, that helps technicians around the world with their medical equipment and professional development. I want to say a very sincere thank you to you and Bob for a small act that has made a profound impact on my life and on others. Justin. And she wrote me back about 2 hours later. And I wasn't expecting a reply back. I was expecting her to think that I was some weirdo he would never remember. She remembers the book. She remembers. And I tell you what, that's probably one of the most satisfying events in my entire life. She wrote back and said, Justin, what great accomplishments you've had. Bob was so glad you reached out to let him know how the book has guided you to such success. I taught Tech Ed Junior at junior high. I taught Tech Ed at junior high for 14 years, and many students used it to create creative team projects. So she remembers that book. Thank you for reaching out. We love teaching at this town. Bless you and continue to share your learning with others. Sincerely, Sheila and Bob. And I thought, holy cow, I've been waiting for over a decade to give this book back. You know, I've been waiting a long time. But every time I go home, my trip is very truncated because, as you guys know, I've been to Biomed for 18 years. Biomeds don't get a huge amount of time off, okay? Especially if you run like a department or a team or something, because when you're gone, nobody is doing your work for you, the special tasks that only you do. So when you go back, you're going to have a hell of a lot of work. So generally, biomeds don't take off like 2 weeks, 3 weeks, something like that. We generally take maybe 1 week off. So you go home, you see your family, do what you got to do, and then you go back to work. And I never had the opportunity to give them back that book. So just sharing that with you guys, that this happened a couple days ago. Hold on just a second. Let me read some of these up close. Your examples of 6-year-olds make me feel like I'm young again. Your commitment to complete a task you promised makes me want to be more disciplined and dedicated. Man, I would love to think that I'm disciplined, but, well, I don't know. I set goals. That's the key. Everything that you're seeing in here has been a goal. Developing that has been a goal. I set a timeline for it. Developing this guy right here, that A-axis, has been a goal. Building shelves, wiring in electrical that I have up here, goal. It's like 1 day builds, okay? Putting in the air conditioning. I want to get this done by lunch, you know, stuff like that. So all these are just little goals, and eventually it all just adds up to whatever it is. Okay, so I don't really consider it disciplined. It's just tiny little goals that I know are achievable, and that's how I do work as well. I have major goals, and then I have minor goals. Like, what do I want to get done by lunch? Guaranteed, This is going to get done by lunch. And that's how I do business. Sorry for the spam. Man, don't even worry about the spam. That's okay. Apple sucks like a Dyson. You guys, is it this book? Hold on. Let me click on the book because I am so curious. There was a website a long time ago called The Way Things Work, and it was a really good, originally published in 1988. You know something? That would probably be it. It has to be a 1988 book because it had been wore out by the time I got to it. And my parents still have that book, and it's at a library still. I think it's at my grandfather's house back home, but we still have that book. I do believe that's the book, The Way Things Work. And on the inside, you guys, if you guys are nerds like me, you will appreciate all the diagrams and breakdowns. That is an updated copy. You can see the images in there. Yeah, that is definitely an updated copy. They have quadcopters and stuff in there. But yeah, like they're going over the telescope, simple machines. You know, they'll go over like how a video camera works, stuff like that. Excellent book. If you guys are nerds, you really want to learn just more stuff, that is a perfect way to do it. So it teaches you about like optics, and it teaches you about microwaves, teaches you about hydraulic door closers, whatever, man. There's a lot of stuff in that book. Very cool. Yeah, thanks for finding that book, man. That's inspirational. Hope you get to meet him in person. You and me both, man. My grandmother is around the same age. Old people remember the younger days really well. I just wanted him to know the effect that he had on my life. Because if you guys don't know, I grew up a redneck on a farm. And I say redneck with pride, okay? There is nothing wrong with that. Anybody that knows the true meaning of redneck knows it is not derogative, okay? We take pride in that, okay? But what I'm saying is even to this day, like I gave my parents one of those Facebook portals, which is a device that allows you to video chat so my kids can see their grandparents. They're absolutely clueless, even though I consider it a very simple device to set up. My parents are clueless, and they throw that ignorance around like it's candy. They're like, oh, you know we're not computer people. It's like, what? You power it on. It says, put this code in. You put the code in, and voila, it starts working. Nope, they won't do it. So I think I'm adopted. And that's how my parents were. It's because of people like the guy that gave me this book and my grandfather who helped me buy my first computer. Those were the people that set me on my life course, okay? And it would be really interesting to see where I would be today if it wasn't for those two people in my life. Very interesting. I'm probably going to fall off this platform. I am not kidding you guys. I am up on a raised platform here, about ready to fall off. Let's see. It's only their short-term memory that gets affected. Well, you were probably right with that. Achievable tiny goals, incremental success. Your method of working is something I read in a book called Atomic Habits. Well, that's good. I didn't know that. It's just something that I developed myself over a period of time because here's a very interesting thing. I know a lot of you biomeds out there are the same way. A lot of people are success driven, and that doesn't mean like we need to be successful. No, it means that you feel good by your achievements, and your achievements can be really small. Like my achievement could be to clear off this workbench, which hopefully I do before I go to bed tonight, right? Well, cleaning off this workbench is a small, tiny goal, and it's achievable, right? Thing is next time I come in this workshop, if this bench is clear, I feel good. I feel good about that. And that is a success-driven mentality. So I like achieving things. And one of the easiest ways to do that is to have a clean work environment. I will make a mess of a flat surface in a heartbeat. Man, my CNC back there was covered with stuff just moments ago because I put the water block on my video card. I made a huge mess of parts and stuff laying all over the place. But in order to do these videos, I have to clean off this workbench. So I had to put everything back where it belongs and stuff, you know. So anyway, that is just the way I am. And a lot of people I know are that way too. We like fixing things because it gives you a result. Your result is now it's working, and that makes you feel good. All right. People that fix things like that achievement. The achievement is that you were able to do something that other people probably can't. And now it's working, and now you have a customer. You visually see that they're satisfied or that they're happy. You had a direct impact on somebody's life. You know, that's why we fix things, and that's why we do what we do, man. Let's see. I should just scoot this laptop closer. Hold on, guys. I apologize. I'm going to move this all around, and hopefully my laptop doesn't fall off the countertop. I'm definitely going to have to study up on that atomic habits. I like reading some of these suggestions that people have for me. I've learned so much crazy stuff from you guys. What do laser technicians do? Ooh, boy, that's a good one. They don't do nothing. I'm just kidding. I've met some excellent laser technicians. Most of the technicians I've met with a company called Luminous are very, very knowledgeable. If they've been with the company for a long time, if you guys don't know, Luminous is probably one of the most notable medical grade lasers out there. They're just an alpha dog. They're one of the best at what they do. Okay, just like Zeiss and Leica are the top names in microscopes. Luminous is just there, and to watch those guys work with the precision that they have is amazing. Now, I've also seen some technicians that weren't so good, but laser technicians, what they do is you either have an error code and you're going to go in and try and remedy that. Often what they'll do is they'll pull laser and put one in its stead, because some of those larger lasers like holmium lasers are just a pain in the ass to fix on site. So you have to pull them and put them off site, you know, where you can break them down properly and test them properly, because lasers have to be tested in a very secure area because of, you know, eyes. But so lasers, medical lasers are such a cool thing. I did several videos on lasers, and I wish I could do more, because there are so many different types and they do such cool stuff. And when I have lasers that come in, because a lot of hospitals here in America, we rent or lease our lasers, it's getting to be a thing where many, many lasers, because the technology has got such a short lifespan, we end up leasing the laser per case basis. Okay, just 1 second. Boy, I gotta fix my platform. I can feel it. All right. I can feel my platform getting a little teetery. So lasers, medical lasers are a very cool thing to work on. And if you did that, you would probably be very happy. They're normally in a very clean environment. The PMs on lasers are pretty straightforward usually. It's I myself like it. I've only taught myself lasers. I know about CO2. I know about fiber. I know about holmium. Matter of fact, I did a whole video on lasers, which people like to criticize. I don't even care about the criticism. I do not care. Life to lights. Where have you been, man? Some of you guys logging in late. That's okay. I'm glad that you came by. But if you're thinking about getting into medical lasers, study up on it. There is a laser certification, and a lot of laser companies will pay. You know, if you're a good candidate, they will pay you to go to school for lasers. Okay. Just do your homework on it, because some of those laser guys have to travel quite a bit, you know, like between states. So here in Houston, like I said, it's a huge medical campus mecca. That means that if you're a laser guy, you're probably going to be traveling in the region. All right. You're probably going to be able to come home every night and see your wife and kids. I don't know. But medical lasers are very cool technology. They're absolutely cool. Learned a lot. Bjorn, have you read that book before? The Way Things Work? Have you Have any of you guys read that book before? It was one of my first introductions to technical nonfiction, and I say that they did a rather good job on it. So I highly suggest that book. You are too relatable. My parents are great, and they try to learn about technology, but somehow I got both of my grandfather's skills. You know, that is so interesting you said that. So you've got one of those grandfathers that can fix almost anything too. Well, I've got two grandfathers that could fix lots of stuff. All right, one of them is really old school. He was the guy that did a lot of woodwork, but he would fix our bicycles and stuff, things like that. But the other grandfather was the one who worked for Oldsmobile, and he was fairly technical. He worked in automotive. Up in Michigan, we have a lot of car manufacturing. So he taught me about fuel injection systems and stuff like that. He was more technical. And that man, back when I was 13 years old, 12 to 13, it was right in that area. I used to ride a lot of ATVs, three-wheelers, four-wheelers, and stuff like that. And I had one of my own, and I would do the typical redneck thing, which is go out and have a blast, like tearing up fields and stuff, right? Well, one day he sat down with me and he made a proposition. He said, I'll tell you what, if you sell your ATV and you use that money, I will go half and half with you and we'll buy a computer. He said, is that something you'd like to do? I remember it to this day. I remember his words, his demeanor, and a typical kid would be like, why the hell would I sell my toy? Shit, I love my four-wheeler. But I did it in a heartbeat. I told him absolutely. And I think about 1 week later, that four-wheeler was sold, and I used that money, and we bought a Packard Bell 486 SX 33 megahertz computer. I will remember that computer to the day I die, because it was mine. It was my technology. I took care of it. I had to curate the drive because hard drives weren't very big, so you had to be very careful at what you saved and what you didn't save. That was before the internet, so the only way to learn it is to sit down and do it, because there was no internet. You couldn't just Google something if you didn't know how to do it. That was back in the day. Oh, let's see. So I can read some more of these. True. My grandmother gives the exact same argument as your parents. It's amazing how similar people are. You're absolutely right, man. You're absolutely right. I got so many stories about my parents and technology. Oh my God. I remember when they were upset that people started putting in ATM machines. They were so pissed off that people were going to start using ATMs because they didn't feel like they had to use technology if they didn't need to. And what if the machine made a mistake on the count or something like that? Even though human error is way greater than machine error. Okay, they didn't understand about the photo sensors, about the recording of every bill that goes through an ATM. They had no clue on how that stuff works. But that's old school mentality. You want to go up to a countertop, you want to talk to a person and get your money out of your account. Me, if I can, go into a gas station, go up to an ATM, get a couple $100 out of there, and go bugger off for the weekend, I'm good. All right. Two different mentalities. Oh, let's see. Both were technicians, but my dad was one that taught me to find a job, and I enjoy and do all day. That is a very important thing. I keep thinking of all the things I could have done with my life, and I'd probably be miserable to this day. Another book that I got from my teacher, a book that covers hydraulics and cooling techniques. Since I got into that book led me into fluid dynamics. It got me into books about airplanes and flight. Man, I was in middle school and I knew about Bernoulli's principle. It's funny how one simple book like that can change your life. My boss mentioned we need more people trained on vents. Should be something I learned. Matthew, let me tell you something, especially in this day and age. Vent guys, are making money, do you want to work on vents? That's the question. It's the only question you need to be asking yourself is, do you want to work on vents? There's many reasons why you might. They bring the work to you often. In many hospitals, the respiratory therapy you give them a list of items that are due this month. They will go out and find it, and they will bring them to you where you sit at your desk and you do vent PMs all day. I'm not that kind of guy. If you do something well enough, you own it. Remember that. And that's vents, that's anesthesia, that's all sorts of stuff, guys. If it's something that other people don't want to do and you do it well, congratulations. Your whole entire tenure at that hospital, that's what you're going to be doing. So remember that phrase. If you do something well, you're going to own it. And that includes ventilators. So if you are doing vents one day and you're like, no, maybe I want to do surgical or I want to learn laboratory or something, not going to happen. All right. Oh, man. Vents are right now are where so much money's at. I know people that have gotten COVID because of ventilators, though. Dead serious. I mean, given, wash your hands, have hand sanitizer, yada, yada, yada. Vents are nasty. All right. Given I worked in operating rooms and stuff was nasty. Right now I'm working in laboratories. Stuff is nasty. But vents right now are nasty. When they say like they wiped it down when they removed it from the room. Yeah, right. You wipe down every hose, every cord. Don't give me that. Have you ever been lowballed in the job interview? Good question, man. Did the military pay more? We have a comedian in here tonight. Yes. Indirectly. Yes. The military paid well, especially if you have a family. Okay. If you're a single guy, the military does not pay that well. And the reason being is when you have dependents and the associated costs with having dependents, like healthcare. Okay. Military, the healthcare is free. Now, if you are looking at getting trained as a biomed and you're looking at maybe using the military as an avenue for that, yes, it's probably the best biomed school in the world, guaranteed. They have millions and millions of dollars on properly taking apart equipment so you can see how it works. They have theory, man, they have electronics courses. The military is no joke when it comes to training biomeds. I'm dead serious about that. If you're thinking about going in, I would suggest doing it as an Air Force person. But you could do Army or Navy. It's just I could do a whole video. I'll probably do a video on that. All right. I'm going to do a video on that because there's so many details about military biomeds. Okay. There's so many details. Like if you go into the Navy, there's different commitments than Army, and Army's got different commitments than Air Force. You should know what all the various forces do in order for you to become a biomed, because it's different for every single branch of the military. So I'm going to do that video. That's a good one. Pascal's law. You know it, man. Oh, boy. Let's see. Have I ever been lowballed in the job interview? When you start out, you will always get lowballed. Every single time. Every single time. And as the market gets more and more competitive, and as technicians generally have lower and lower skills, and I'm saying that honestly, generally a lot of technicians are guys that ship stuff out. And some shops, that's the way they like doing business. And if you are trying to get into a shop where they want you to ship a lot of stuff out to manufacturers or third-party repair centers, if you are going into one of those shops, expect to get a lower pay. Guaranteed. Because that's all they think of you as a technician, as a middleman. And why should they have to pay you? That's facts right there. Okay. That's why I started this channel, is I'm trying to increase everybody's awareness of what stuff is and how it works. because I want you guys to go out and make more money, because when you make more money, I make more money. All right. That's a fact. We're in this together. And the way that works is, let's say the overall job market around Houston, somebody advertises a Biomed 3 position, but they want to pay $60,000. Somebody out there might take that position for $60,000, maybe. I don't know what I would expect out of that technician. All right. If you go in there and you say you want the job for 70,000, I go in and say I want it for 80,000. Okay, but I have X amount of, let's say I have a decade more experience than you, something like that. I'm probably going to get it. Okay. So there are some intricacies in there, but if you go in and say you want it for 60 and I go in there saying I want it for 80, they're going to look at me like I'm crazy. Okay. So if you guys make more money, I make more money, and we all make more money. Because like I said earlier, the one thing that is definitely going to happen is their hospitals are going to want you to do more with less. Okay. So get your money up front, get it on paper that's how much you're going to make, because over your tenure at that hospital, they're generally going to want you to do more and more. Okay. So if you start at 60K and they want you to do more and more, don't expect incremental pay to go along with that responsibility. It doesn't happen. Get your money up front and then live up to your pay. Don't expect pay on the back end. Doesn't happen, man. Let's see. What else can I answer for you guys? Have you ever repaired or troubleshot autoclaves? Absolutely. Autoclaves. Now, mind you, there's a lot of old autoclaves still in service everywhere, right? There's a lot of tabletop autoclaves. There's autoclaves that would take up half this room in here, okay? There's a huge, huge swath of what an autoclave is. But yes, we all, every single biomed I've known has to some degree worked on autoclaves, all right? Know your schematics. That means your vacuum and your pressure schematics. Know your plumbing schematics, electrical schematics. You got to study on schematics if you've never done them before. I don't think autoclaves are that difficult once you learn what's going on in your schematics. Although the newer ones are, they all have computers embedded in them, and usually the problems with the machine are related to the computers. I recently have had some new Steris units. I don't know if their computers that they put in there are not conformal coded. Conformal coding is, let's see if I got any of these that are coded. Is this one? Where's this one? This one looks pretty close. Conformal coding, when you look at a PCB and it's really shiny, like I don't know if this camera is going to pull it up, and some of the components have a shiny layer on top of them. Conformal coating is a waterproofing or a fluid prevention. And a lot of industrial computers, like the little ones that control industrial devices, they all have this coating on top of them. Now, obviously, this power supply that comes out of that display does not have anything like it. But I do believe that power supply over there does have a conformal coating to it. And what that does is if you have liquid that gets on the PCB, it will not destroy the PCB usually. Okay? It's a prevention. It's like a dip coating that they put on a board to protect it. And you would think around sterilizers, when you're dealing with steam, fluids, condensate, just a really nasty environment for electronics, you would think they would conformally coat the boards inside that mini computer that control that device. But they don't. And I know they don't because I've gone through two $2,000 computers in 1 year. All right. And oh, it's so frustrating because you would think they would spend just a few extra cents and dip those boards, right, to protect them, you know, from that nasty environment. Anyway, yeah, autoclaves, we've all done them, man. And if you ever have any questions on them, let us know, man. There's so many of us that have done them. Thoughts on CBET? Woo! I know I get this question every single time. Okay, well here's something. I myself was not going to take CBET because I am not going to spend money because I'm pretty much salary capped right now. I'm pretty close to as much as I'm going to get, and I'm not bragging about that. What I'm telling you is the reality. So normally with a CBET, there's a small amount of pay increase related to getting a CBET. Now it does often help you get a job sometimes, but if you have a resume that's already stacked out, you know that CBET, it's like eye candy at best, right? I know a lot of CBETs that couldn't tell you nothing about what I got right here in front of me on this table. It's just, it is what it is. It's a certification. I've never really supported it. I was going to test for it multiple times, and I just, oh my gosh, guys, the CBET. Although somebody approached me in this last week, a gentleman from Crothel, saying that Crothel would like me to go after my CBET, and they would pay for it, which I don't know if you guys know me, but I love free shit. So, I mean, if somebody's got to pay for it, then, you know, okay, well, now you kind of got my attention. It's just, it doesn't really do anything for me. I've answered this question for other people before, you know, whether or not a CBET or a manufacturer OEM training is going to give you more pay. And every single time it's training, the CBET might give you a small pay increase, small, but compared to getting an extra training on like autoclaves or surgical tables, or if you get a ventilator training like we talked about, there is where you're going to get your pay increase, and probably a nice one. CBET, expect like maybe an extra $1,000 to $2,000 a year, maybe. Versus if you go and get ventilator training, you might get $5,000 to $10,000 extra per year just for that. So there you go. Do I support CBET? I don't know. That's a good question, man. I've written them, and I've had interesting conversations with the people that administer the tests and stuff, and I don't know. Some of their questions are a little goofy. They ask about some real crazy stuff that is not really applicable to who you are as a biomed. They ask you about details about garbage, in my opinion, on some of the stuff. And there's some stuff that I really think that we should learn, like clinical applications. I really think there has to be a heavy focus on clinical applications of medical equipment, because if you don't know how they use it, you don't necessarily know what could be wrong with it. So I think that's the big difference between a junior biomed and a senior biomed. Is a senior biomed knows how the users use the equipment. A junior biomed might just walk up and know that it's a power supply, you know. That's it. That's the big difference between junior biomeds and senior biomeds. It's not that we know magically what's going on with that device, but the senior biomed's going to know how they use it. He's going to know the clinical applications of it. So that's the biggest difference. Let's see. So I can get back to reading these questions here. Do you know of any spray-on or easy application conformal coatings you can use in consumer electronics like laptops? Absolutely. If you go on Amazon, eBay, both places have it at a, you know, don't go to some place like Granger, all right, because you're gonna make me say something that I'm gonna regret later, all right? Because don't go to Granger, all right? Go to like Amazon or something like that and just type in conformal coating. You can get the spray-on ones. Yes, it's in like an aerosol can, or you get the ones that are in like a glass jar and you paint it on. Depends on the size of the PCB you're doing. Like I don't know if you guys know, under the thing here, I've got a bunch of like quadcopters and stuff. And with quadcopters, the board is only like that big, right? So you're going to get the conformal coating that you paint on, because if you land in water, you can probably salvage your board. But if you don't use conformal coating, you just trashed your board. So in those cases, I paint it on because it's a small PCB. But if you got a big one, then spray, of course. And the one area I will tell you right now, I suggest if you guys are Biomeds currently, if you guys have those Gaymar brand heater coolers, they're still everywhere. You guys know what I'm talking about. Heater coolers, they have a water bath inside, and all that humidity comes up inside it. I wish I could show you a photo on here. Just look up Gaymar, Gaymar heater cooler, okay? And inside this device, these are old, by the way, there is a water bath that heats up, and all that steam and stuff rolls around inside, and there's a control panel at the top, and the back of that control panel always gets destroyed by heat and humidity. Why don't they conformally coat those PCBs? It is just driving me freaking crazy that in 20 years that they couldn't figure that out. And it's like guaranteed money for them, right? But if you guys have any of those heater coolers, trust me, pull them apart, spray conformal coating on there, put them back together, and welcome to the next 10 years of their life, because they're going to keep working. Let's see. I feel the same way about CBET. I do it if it's free. Doesn't make or break an experience Biomed. No, it does not. Absolutely not. Let's see. It's because I'm going to be using it near a CPU. So yeah, there are non-conductive, non-flammable conformal coatings, and there's a whole bunch of them on Amazon. Just look it up. There's some good ones on there. I do not have any here at the moment because I've used up a lot of my stuff when I built that CNC over there. A lot of those boards are protected because dust and humidity, even though I got air conditioning, so it, gets rid of the humidity. Let's see. I've troubleshot Tutnor and Midmark autoclave. Ooh, Midmark. It's been a while, man. I've never heard of Tutnor. Never heard of that. That's insane. 800 degrees C. That is crazy hot, man. Tutnor likes to overcomplicate everything. Well, that's probably why I've never heard of it, because nobody buys them. I don't know, man. Let's see. I've used it from the brand Motip. I've heard of Motip, I think. I don't know. You never know where these conversations are going to go, you guys, with these live things. Here we are talking about conformal coatings. That's random, but that is need to know stuff, man. As a biomed, you should know what technical terminology, conformal coating, and because you have to look it up when you need to reorder consumables, and you have to know that it's electronic safe, and it could save your ass. Okay, you spray certain boards down with conformal coating, especially if they're around water, it's going to save the board. So if you ever pull something apart that is around a liquid environment, spray that bad boy down and put it back together. I just looked it up. You can tell it's a disaster waiting to happen. I don't know how much it costs for the manufacturer, but 90% of electronics should be coated. Oh man, absolutely. That's such a strong feeling. If you can't tell, either a war just started or somebody's blowing off the last of their fireworks. Houston is nuts about fireworks. I swear to God. I had some feelings like I was back in the military all over again, and sound like I was downrange because of the amount of explosions that were going off all night. These guys are hardcore out here in Houston. This stuff went on all night. I do believe that this board is coated because I don't know if you can see it. You can see that really shininess on the board. That's usually the first indicator that it's really coated. I should have should pull out one of my quadcopters so y'all can see it. It's a cool product though. What else can I answer for you guys, man? Tell you what, let's get back to power supplies. Man, I am so run off track because of you guys. All right, I wanted to talk about the output stages of these power supplies because this is probably a major thing when you're trying to troubleshoot these bad boys. So on medical grade power supplies, on so many of them, here, I'll stand up for this one. So you can see right here, this guy right here is your voltage adjustment. It's your trim pot, so you can adjust the details of your outputs, all right? Well, one of the other things that you'll notice is I've got some jumpers right here, all right? Let's see if I can tilt this guy. Oh, yeah. I'm not getting the right angles. Okay, so you can see I've got jumpers right here, and let's see this guy here. Oh, you can see, well, this one's got your trim pot, and then right next to it, it's got S minus and S plus. Mind you, this is the output, this is the input. You can tell the input because it's two prongs, line and neutral. Output has got all your different power stages. But over here, it's got S minus and S plus. S minus and S plus is often your standby power, okay? And standby is what many of these power supplies have. And it's what I was talking about with this guy over here, how T2, it's got a large transformer, that's T1, and they'll often have a smaller one called T2. Your standby transformer is going to have a little electrical signal that's going to go out to your control board and your power button, and it's going to tell it to turn on. Okay, that's what it does, and it basically makes sure that your power supply is not running full tilt all the time, because that would burn electricity. You know, power supplies, even when they're not outputting something, they have a natural parasitic loss of power. Okay, and that's because they have transformers, and transformers just naturally eat electricity just because it's on. All right, so going back to these little guys right here, when you see jumpers near the output of a power supply, they're often to imitate the standby power, like the power button. So this is basically enabling and disabling standby power. So in other words, normally when this guy is connected with all these pins, one of these pins is probably like 5 volts that goes out to the power button, and it's looking for 5 volts on one of the other pins, okay? Because that would signify you pushing the power button, which closes the circuit, brings 5 volts back, and it turns it on, right? That's your standby. Well, what this does is you move this jumper here to these pins here, and now you just disabled power, the standby power. In other words, the power supply is always on, which could be good. If you have not so many power supplies around, you can't figure out why the stupid thing's not turning on, you might want to read up on the manufacturer of your power supply, because if it has those jumpers, you can just short them out. That way there, it bypasses the image processing board, bypasses the power button, so you don't even have to troubleshoot that garbage. You just move these jumpers over, and now you start measuring voltage on your proper pins. So if these ones over here are ground, and these ones right here are 12 volts, these ones right here are 5 volts, just hook one lead here and start testing, all right? It's that simple. So that's standby power, and that's something very important if you are working with medical grade power supplies. They often have standby. See how it's got this little connector down here? That probably runs over to your control board, and that probably has standby. In fact, hold on. They actually have a breakdown of your pins right here. Well, I know for a fact it's got standby. Look at this company. These guys are awesome. You can see right here, it says on the top line, it says 28 volts, 8.9 amps. On the second line right here, you can see voltage standby, 5 volts, 0.5 amps. So that tells you that this one here has a standby, and that you either have to short some pins, which it's got a nice breakdown of what's on your pins. So you short certain pins together, and that turns it on. So if you walk up to a power supply and it's not turning on, do you really know if it's the power supply that's bad? You don't know, because if it's got standby, it's looking for that signal to turn it on. So that's just something that you guys should be well aware of. Get the data sheet on your power supply and read that bad boy before you troubleshoot. It could save you a lot of time. All right, let me get rid of these little guys because I'm going to put this big bad boy on the mat. And I'm going to show you some stuff on this guy because this is an impressive, probably crazy expensive power supply. So this guy right here is an insane power supply. And it's insane because it's got every feature that you can think of. It's got different power phases on the output. Look at these ones right here. It's this is your DC out, but this is for high current. I have no idea what this guy's doing. It's probably powering a motor driver or something because you can see. Oh, holy cow! I'm getting the wrong angle. Sorry, guys. You can see that it's got these huge mounts right here for the hold downs. Just a crazy transformer. So you can see the transformer here, big old transformer up here. So let's go through this guy exactly how I showed you with the simple one, because like I said, power supplies are so the same, and I'm going to prove it right here. All right. Let's see if I can get this guy all in frame so that y'all can follow along. Okay. So you can start out right over here. It says line and neutral, L and N. That's your AC input on this one. Okay, and just like this is your AC input on this one. Then it goes in, we have a couple thermistors. We have a single fuse. Now, I told you guys about certain ones that will only have line or neutral fused and other ones that have two fuses because these ones here that have two fuses are often used in medical equipment that could go into isolated power. So when I said it could go into isolated power, it's line and neutral both have 60 volts on them, all right? This fuse right here is only for line, right? So it's got 120 volts from this. The other one is neutral. Why would they fuse it for a standard device? Mind you, this comes out of a TV. This one comes out of probably a crazy expensive device. This one here probably is a power supply to a surgical device. And there's several reasons why I think that. One of them being the two fuses. Because in surgery, you have isolated power in many of your operating rooms. And that means that you have voltage on both line and neutral. And that tells me kind of an indicator of what this guy is. This guy here, I have no clue what this device belongs to. I can probably look it up based on part numbers and stuff like that. But just because it's got one fuse here tells me that this is probably not a power supply from a surgical device. But take a look at this, guys. This thing has fuses all down the side. Let me flip it around so you can see it. Tell you what, let's take it back a step. I was going to show you guys the flow through the power supply. Let's finish that up real quick. So your power comes in, goes through your filtering components. Look at this guy right here. I was telling you guys about that bridge rectifier, which you can see so well right here. That converts your AC over to DC, all right? So you got your bridge rectifier, this big guy right there, that wide one. Your bridge rectifier puts it into DC, and from DC, then it's going to go into some MOSFETs, and those MOSFETs are just like right over here. You got your power MOSFET on this guy right here. This one has got, it looks like your power MOSFET's right here on this guy. And it basically goes and it segments. So you're going to have your, what's going on with this? This one's got several different phases going on. So this is, I can't even show you guys a flow because where I would expect to see MOSFETs, I can't tell you I got some CRs here, but look over here. Look at all these power phases. Look at all this, man. This is something you do not see on most power supplies. You can see right here, I've got my rectifying diodes. You can see it says D17, so you know it's a diode right there. And I've got D16. So right here are your diodes for your output power that turns AC back into DC. And then from there, it step ups or down to whatever you need. So I'm going to step it. It's probably going to go through here. It's going to step. And then that means, guys, I'm just, I've had too much caffeine. I am so sorry, guys. So let's say you have your power go through here. It's coming in at 50 kilohertz. And let's say it's coming through at 60 volts, something like that. It's going to come through here and it's going to step down. Because remind you that it's a 12 volt power supply and 5 volts. So it's got to step it down quite a bit. And then it's going to go through these diodes as, let's say, 15 volts AC. So it's going to go 15 volts AC through these diodes. Now it's going to be 12 volts DC. And now it goes into your filtering caps, smooths it out, and you actually have your 12 volts to power your magical device. This guy is so much crazier. Oh my gosh. I wish I could tell you everything that's going on with this one. So you have your power come in. It's going to first get rectified, go into high voltage DC. You can always tell based on this giant cap. And then it's going to get switched on and off. It's going to go through a transformer. And then it's going to get rectified. Remember, you have to rectify it back to DC. And then you got all these power phases right here. Guys, this is so insane because this board puts out what, 5 volts, it puts out 12 volts. What else does it put out? Probably 3.3 volts, because that 3.3 is what you use for microprocessors and stuff. But here's one of the things I want to point out to you guys is every one of these power phases has a fuse. It's got a fuse. There's tiny little fuses. See this guy right here? This is a fuse. This one right here is a fuse. This one right here is a fuse. We got a fuse here. And then we've got this bad boy right here. There's fuses all over this board. So crazy. And remember, I was telling you guys, near the output, you're going to have jumpers. And that's going to change the properties of the board for like standby power. Take a look right here. Here's your jumpers. So your jumpers are going to enable or disable standby power. So you can use that for troubleshooting, or you can use that to, disable the power button on something. It's true. You can have a device stay on all the time just by flicking one of these over to the correct pins. So this is just an insane, crazy expensive board. I bet you this one here is several $1,000s. Guaranteed. This board, this power supply right here is probably between $2,000 and $5,000. I don't know what this device goes to. I'm gonna have to find it out, but I know that this is a crazy expensive board. So all these guys, once you understand the flow of electricity through it and how it gets routed, they're really not that bad. If you want a better explanation of the stages of a power supply, check out my video. I did one on external and internal switch mode power supplies. These are obviously internal. Go into that video and it goes into so much more detail where I actually segmented it out and explained every different stage. Here I am just doing this completely ad lib, and I have never seen these boards before the stream. I did not see any of this. So if you're like, man, this guy doesn't know what the hell he's talking about, you are absolutely right. I have no idea what the hell I'm saying because I've never seen these boards before right now. So I just packed these in my tool bag, and I said, hey, we're gonna figure this out together, right? So I packed them up, brought them here, and I figured I would look like an idiot discussing them with you guys. I don't know. Let's see, what else can I read over here? Just looked it up. You can tell it's a disaster. it is a pretty easy way to tell if it's coated. It'll be shiny, and it's dead giveaway, man. Especially the IC chips. If you got IC chips and you can't really read them, it's probably because it's got conformal coating. So you just, take something relatively soft and scratch off the coating so that you can read the numbers on your chip. That's all there is to it. Power supply is the reason you joined the stream. Well, I'm sorry. I do just completely go off tangent. Also, to mention, a Fluke non-contact tester can detect 5-volt DC from a USB wall PSU. Really? Well, that's interesting. I'm going to have to test that one out. I didn't know that. Well, I know that based on the principle of the little tip, that it has to have like a fluctuating power. If you guys aren't sure, if you've never heard of it, there's a YouTube channel called AVE, Arduino versus Evil, and he does a breakdown of all sorts of tools and all sorts of devices. And lately, he's kind of gone off on some really weird videos, but in his original ones from years ago, I've been a subscriber of his for years, man. And his first ones, it's just him sitting down with like a device, and he breaks it open and he goes over what's inside it. One of them he did was these guys, and he goes over the principle of how they work. And I do believe he's PhD or something. It's like a huge internet conspiracy of who he really is. Although in one of his videos, I kind of figured out who he was, and I haven't released that to anybody. But one of his videos made a slip up, and I called him out on it and secretly, and I think he remedied it. But anyway, Arduino versus Evil. I highly suggest that channel if you haven't seen it yet. Mr. Seth, thank you very much for that. I am a maniac, and this, like I said, I apologize, guys, if you can't tell. I haven't slept very much lately, and I am operating straight on coffee and wine at the moment. So if I'm just going off on a thing, just let me know, man. EEV blog or SDG electronics were clueless the need for double fusing. You know something? I will have to write those guys and let them know. There's often a indicator as to a medical grade power supply. So you can see the part number. It's usually in the very last digits. It's either the last digit or it'll have like a -M or a -1 or something like that at the very end of the part number. And when you read off that part number to the company that makes these, as soon as they get like that exact part number, they're going to be like, oh, yeah, we can't sell those to you, because there's almost always a special part number for that device, and they have some sort of agreement where they can't sell you that exact number. But if you go into their parts catalog or into their data sheet, you start typing in the part number and you do your research, there's an exact one, exactly like that. That is not a medical grade power supply, supposedly, or not one that's in their little agreement with a equipment manufacturer. And it's the exact same part. But that specific part number, it's usually the last digit signifies it as either specific to a device, like they have an agreement, or it signifies it as a medical grade power supply. But the double fusing is there because, unfortunately, in some environments, like wet locations in the United States, we have isolated power. And isolated power means that your neutral, which normally doesn't have voltage and current, does. All right. So, of course, you have to have it fused, because if you had a short, even though it's on isolated power, well, you get it, I did understand MOSFET. Oh, okay. Well, I'll tell you what. Find my video on power supplies. All you got to do is do a search, go into the channel and do a search on power supplies. And let me know if that answers any of your questions, because that video was thought out. I think it was more scripted than this. And I did tons of research in order to make that video. And if you still have questions about any of this, let me know, man. I'd be happy to answer them. Now, I think the gentleman from Ethiopia that was going to join us, I don't think he's here, so he's going to have to catch this in hindsight. But if you guys ever have any other questions on these power supplies, do let me know, man. Because I understand that I'm just going over this like crazy fast. I have looked at so many videos on power supplies and stuff like that on the internet, and they all seem to be missing something, like a real breakdown of like this section does this section does that. That's why I made my video on power supplies so specific. Like I even put boxes around areas just to let you know this section does this, because that's what most people relate to. I want to see, what does this section do? What does this section do? Okay. But I can tell you, power supplies are the one item that fail the most, and especially with TVs or displays or non-medical grade items, the output capacitors are something to be wary of. They have problems. If you pop a fuse in your power supply, I'm telling you right now, there's something bigger going on. It's probably one of your MOSFETs are shorted. So if you take anything out of this video, electrolytic capacitors, they go bad, and they go bad all the time. The other thing you should take out is MOSFET short, okay? Power transistor short, diode short, okay? So transformers also will go bad, especially if you have a device that vibrates around quite a bit. And that's one of the cool things I like about this one. You can see how they put this extra shielding around it to minimize the amount that coil is vibrating around, versus this one here, they only put a little bit of Celastic. That's what that compound's called, that they squirted at the base of that capacitor. Everything else here is not really supported. So, it is what it is, man. Yeah, a lot of this stuff is not supported. Matter of fact, look, I can pull off heat shrink tube and stuff. So this is definitely not a medical grade power supply. But this one here, look how nice that is. All nicely done up. It's got your RF barrier on it. That's a well-made part. I guarantee you this bad boy is expensive, very expensive. I'm gonna have to give this back. I'm gonna take these all back to the hospital when I'm done with this video. But let's see, what else can I answer for you guys? Sneed, I promise you, if you have more questions, man, just let me know. If you have anything specific you'd like to know, check out my video first, and that'll give you some more details. If you hold the tester against a USB cable, then it beeps. No shit. That's interesting. Okay. Well, Bjorn, I don't know if you've seen the video I did a while back. I have a circuit tester, which is actually in the boxes over here. I did a video on doing wire testing using a circuit tester, which it's a device that you clip on one end of your wire, and it basically is for cable tracing for back in the comm closet. So you plug in like a Cat5 cable at one end, that's your tester. You go back with the probing pen and you like go in the comm closet and you search around everything. Well, you can use that for testing too. I take my cables that plug into the tester and I clip them on one end of a cable, and then you use your testing pen and you go down the cable until you hear the beeping stop. When it stops, you know you've got a break. So you could mend the cable there or replace it or whatever. I have had to do that several times. And the funny thing is once you come up with these methods for testing stuff really quickly, it's, you know, in the amount of time it takes somebody to whip out this guy, I have this guy right in my tool bag. It's super lightweight. I just turn it on, and you can go through it. You can go by your transformers and see if it lights up and beeps. You know you've got power there, right? So no need to whip out your multimeter and get all technician fancy on you. You can use this guy to test the power supply to see if it's got power. You know, this is a cool little tool, man. Given it only works on AC, but it at least tells you if you got power coming into the power supply. At that point, you know, here in America, we just change out the power supply. If you got power coming in, but you got nothing coming out, just buy another one. That's what we do here. Let's see, what else can I say for you guys? Josh says, thanks for doing these videos. Been a Biomed for 11 years, but I'm embarrassed to say I've never really worked on switch mode power supplies. Well, that's okay. A lot of people don't. I did learn and built linear power supplies in school. Well, that's cool. I actually have a custom power supply that's in my cabinet over here. You know, switch mode, it's the switching noise that's injected into the USB. Oh, no shit. I didn't even think about that. You're right. It's because it's what, a buck converter for those USB 5 volts. I think it's a buck converter that's in there. It's a really simple circuit that kills the voltage. It decreases the voltage to a working value of 5 volts. And I'm pretty sure that's probably what's in there. And that's probably why it's noisy too, is because buck converters can be really, it's not the cleanest power, but I mean, what do you need to charge your cell phone? Because the linear power supply doesn't let the tester beep. I stopped watching your videos at the 100 mark, 50 more to go. Oh man, oh my gosh. You know, it's absolutely crazy for me to hear of people like going through all my videos and stuff. I mean, sometimes I think I just ramble on and I talk too much, but I learn as much from you guys as you guys learn from me, I hope. So it's really kind of crazy because I think I have like close to 200 videos now, and maybe more, maybe less. I don't even know. But every so often I just see some cool stuff and I want to talk about it with people and I make a video on it. It's definitely a little crazy. Is there anything else I can answer for you guys? It's probably getting late for a lot of you. I mean, hell, for me, it doesn't even matter. But for you guys is what I'm really curious about. I know I went over so much stuff. I would love to go into more detail on some of this stuff, but honestly, I think I just bore the hell out of you. But what I can do is if you have a question about something, just let me know, and I'll tell you if I made a video on it or not. And because right now I can give you answers, but I in some weird way I think like these are half-ass answers because someplace I probably made a video where I gave lots of detail, like power supplies. But there's the gentleman from Ethiopia who wanted me to do a late night video. He had, you know, obviously in some countries they don't have the luxury of just going out and buying another one, right? So they got to fix what they got. And in a case like that, I expect him to watch this video. I just want you to know, you got to switch your meter over, okay? Get used to switching between AC and DC as you inspect these. But most power supplies, capacitors, and if you pop a fuse, then now you got to short someplace. So check those MOSFETs, pull them out of the circuit, you know, and check them again. And they do go bad, guys. I've got a whole bunch of them, man. If you guys ever work on like car audio amplifiers, you know, car audio amplifier is so similar to this guy right here. They operate on a lot of the same principle as these switch mode power supplies. And it's, I wish I had one here. I could pull it apart and show you guys. But there you have power transistors and MOSFETs that also go bad in shorts. There's a lot of YouTube videos out there about repairing car audio amplifiers. And if you want to learn about inspecting MOSFETs and stuff on the board, there's some excellent videos where these guys go out and they fix like car audio amps, and they'll show you like, yeah, you just run down with your probes, and one of them will beep. Now you know that one's the shorted one. Pull it out of the circuit, put a new one in. There's power supplies, they can be fairly complex, like this guy here. This is just like the worst situation. If this guy went bad, I don't even know what I would do, because somebody is gonna have a bad day when this guy goes bad. It's so expensive. You can tell by the amount of componentry and the effort that they put into it. Maybe another stream about limb. Okay. Well, Bjorn, have you seen my video about line isolation monitors that I put out? That one, it's a little bit dated, I think. Given my current hospital that I'm working for has got some really really old limb panels, really old. I've done demonstrations on what the line isolation monitor does for doctors in the operating room. I will take my knife out and I will shove it in the electrical outlet because they think that they just got shocked by a device. And to prove that they didn't get shocked by the device, I'll take my knife and I'll jam it right in the electrical outlet. And the doctor's screaming, "No, don't do that!" And it, sometimes you need a physical demonstration for why we have line isolation power. But okay, yeah, I can do that. That's I actually don't have to do the video there because I could do the video here since I have a major component of it right here with the isolation transformer. It's going to act the same. It's just I don't have the limb monitor. Maybe I can obtain one because like in my line isolation power video, which is surprising, it's done so well. I actually show like a line isolation panel and what goes on inside it. But yeah, man. Dim bulb current limiter. Because an RCD won't trip behind isolation transformer. Oh yeah, yeah. You have an interesting situation there. Okay. Okay. Well, that's an interesting one. I'm gonna see if I can obtain a line isolation monitor and I can show you guys. If you haven't seen it, what me and Bjorn are talking about, go and take a look. I have a video on line isolation power and limb panels, LIM. Go ahead and take a look at that video and tell me what you think, because that was one of my first videos I ever made, and I made it because I had to explain what isolated power was to some electricians that were at my hospital. And it's true, often you have to be like, hey, Mr. Biomedical, how's it going, man? I was telling everybody about your channel here, so thank you for joining this stream. I appreciate that. It's Mr. Biomedical. Check out his YouTube channel. He's got some pretty interesting teardowns, and it's really good to see somebody that's out there creating content, because we all love watching it, man. Visual alarm, but doesn't interrupt the power no matter what. Hey, Bjorn, do you guys have GFCI outlets over there in Belgium? GFCI, that's ground fault circuit interruption. We have them in bathrooms, laundry rooms, kitchens, stuff like that. In fact, I've got 2 GFCIs. I just did a video on GFCIs not so long ago. Okay, I kind of figured you did, because you guys are definitely up on electrical codes. Well, a GFCI does the same thing as a limb panel. It just it just disconnects the signal, whereas we don't want to disconnect because we're treating a patient. So 300 milliamps for the entire house, 30 milliamps for the wet rooms. Really? Okay. For the entire house. You have the entire house on a GFCI breaker? Like your mains breaker is GFCI for the whole house? Man, see, I learned so much weird stuff from you guys, man, from all around the world. That is so crazy. That is very interesting. And in fact, if you guys don't know what we are talking about, it's so cool having all my tools right here. So if you guys don't know what we're talking about, right here I have a GFCI tester, and I did a video on GFCIs because there's something that we should know about. This guy right here will basically short a couple pins together, and it will test it at 20 milliamps. So your GFCI should break at a very particular current, and this tests it. So you plug it into your GFCI, you find them in your kitchen, your bathroom, your garage, and you press the button. And if it trips, it's good. If it doesn't trip, you need to replace it. So we do have a specific tool for that purpose. RCD won't work with L1, L2 without a neutral. That is so interesting. I'm gonna have to do some research on that, man. That's very cool. Mr. Biomedical, thank you for joining us. We were talking about power supplies, and I was going, man, I've gone over so much stuff about I got a variety of different power supplies here on my bench, including this bad boy, which comes from a device that I have no clue. I've got to put this one back together because I took the cage off it. I've got some small examples. That's a very generic power supply. You find these all over the place. But just a general overview of what normally goes wrong with them and the different segments of power supplies. Kind of a follow-up in more detail on medical grade power supplies versus non-medical grade, because there are some pretty good examples here. But with what I got, I mean, some of these are like the epitome of medical grade power supplies, and then some of them are not. I mean, like this one here has a double fuse, but you can tell like they already did some cost saving measures by eliminating some components. But I've seen so many of these boards go bad, it's not even funny. You find these in like network routers. You find them in a lot of simple medical devices, you know, stuff that's in your telemetry system. These things are all over the place. So that's why I have extras. Just a generic 12 volt power supply. I think it's what, 1.5 amp or something. What are you? Oh no, this is a 24 volt 3.2 amp. So this is not the specific one I was thinking about, but whatever. An RCD, residual current device, life-saving device, which is designed to prevent you from getting a fatal electric shock if you touch something live, such as a bare wire. Yeah, we don't call them RCDs over here, but that is very interesting. The electrical codes over in Europe in general are just interesting. And some of the things that you guys do, I wish that we did. Some of the stuff that they have, like your prongs, like you can see how ours are almost equal. So they pretty much touch almost at the same exact time. A lot of European style plugs will have the ground significantly longer than your hot, so that you have more connection for your ground than you do for your other ones. There's so many safety features built into their electrical. It's such a, I really appreciate my tour over in Europe. Earth leak switch. Yeah. I'm gonna go ahead and copy that link, Bjorn, and I'm gonna do some research on it, because we do have something similar to that. But that's not part of our electrical code. At best, we have to have GFCIs within like any electrical that's within 3 or 5 feet of a water source, and if it's exterior of the house, it has to be on GFCI. And you know, now we have GFCI breakers, whereas you know back in the day we didn't. So now you can have entire areas like this garage on, you know, breakers over there instead of having actual GFCIs all over the place. This is why, you know, I can have this stuff up here without having a GFCI on it. It's because I got a breaker. Man, is there anything else I can answer for you guys? I am so excited that we had a very good turnout for this first episode, this first show, the first whatever you want to call it for 2021. I do hope that we all have a very good year, but you know what they say, hope for the best, prepare for the worst, because I hope you all stay safe. Any of you guys that are definitely out there around medical equipment, use gloves, wash your damn hands, please. There's some serious bugs going around. If you haven't heard, now we have 3 states over here in the United States that have this new version of COVID, and it's supposedly more contagious, it's more extreme. Who knows where that's going to go in 2021, but I do know one thing is a lot of people that have caught COVID in my work environment, it's because they don't always excuse me, they don't always practice proper hand hygiene and stuff. I mean, when I come into the shop, I put my stuff down, and the first thing I do is I go to the sink every single time, man. Before I sit down to eat lunch, you betcha, of course I'm going to wash my hands. Do you know how many people don't do that? I am so serious, guys. I am so serious. There's so many people that don't do that. Hell, I've seen surgeons go in and use the restroom and then leave without washing their hands. I kid you not. I kid you not, guys. It happens. There are some real disgusting people out there. So stay safe, guys. Wash your damn hands and just be prepared for the worst. Because I have, you know, I've got little kids and stuff, and I have to be extra careful because of all that. I still don't understand why biomeds need to learn plumbing. Really? You don't know why biomeds need to learn plumbing? Well, I can tell you why. You're going to have to learn plumbing schematics if you are going to work in laboratories. You're going to have to know plumbing schematics if you are working on any let's see, ultrasonic cleaners. If you're going to work on any sterilizers, you're going to have to know plumbing schematics if you are going to work on physical therapy baths. If you are, I mean, I could go on and on. There's so much stuff. I mean, you have to know plumbing schematics if you're going to work on just analyzers, because I mean, they have hoses and stuff inside the machine, and they teach you, you know, about check valves and solenoids and all that, and you have to understand the symbols on, you know, the fluid or the pneumatic schematics, and that's why we have to learn it. You should always want to, if something is connected to your medical device, you should either know it or you should want to know it. That's how I feel about Biomed. I mean, if you have some sort of utility that comes in, I've got steam that comes into my sterilizers. You bet your ass I know where the steam plant is, because we have a central location where the steam's made. I know where the control valves are to shut that stuff off in case I need to bleed off the line. That's something I don't have to know, but you never know when you need to know it. So plumbing, sweating pipes, I'll tell you what, man, there isn't always going to be a contractor that's going to be able to do it for you. Sometimes you're going to get that crazy call in a hurricane or something. I don't know, maybe you're living in a desert. You might not have hurricanes. I know we do. Sometimes you just got to do stuff that is superhuman or unexpected, and it's always nice to know, okay? And part of being a biomed, you guys, is to learn as much about everything that's in your hospital as possible, because whether or not you do it, when the time comes, you're expected to know it. That's the crazy thing. Is I had some people asking me why the elevator was not opening its doors, okay? Or why the elevator is not closing its doors. And I showed them about the detector strips, you know, that are opto. It's basically the same thing as your garage door sensor. All right, it shoots out an infrared beam, and there's some receiving photosensors on the other side. And I showed her that because you were, you know, your cart wasn't all the way in, that it, even though the door wasn't going to hit it, you were still technically blocking those photosensors. So I didn't have to know that as a biomed, but I explained it to her about the photosensors around elevator doors, and now she's smarter too, right? So that's what it is about being human. So we share our knowledge with one another. Dialysis, you know it, man. Dialysis, Jesus. Oh my gosh. Yeah, you better understand your plumbing with dialysis. DJ, you are absolutely right. Even if you don't know everything, you should at least want to know. All right. It's such a complex answer. We know everything else to a degree. Might as well. Yeah, because like I did in my what's a biomed. We are the plumbers. Whether or not, you know, you have a plumbing department at your hospital. Hell, some of you guys that are watching these videos live on islands. Islands. You think there's always a plumber that's going to be able to help you out in the middle of that island? No. You might be the guy that does everything at that hospital. It happens, man. I've been asked to go and declog toilets. Okay. Are you giving your opinion over there? Hey, hey, hey. That's what I thought. Crazy dog. As they get older, they get crazier. But I've been asked to unclog toilets before. You know, you never know what you're going to get, man. Sometimes you don't have the luxury of saying, hey, that's not my job. So it depends on your hospital, depends on your location. I mean, hell, including some of the stuff I was asked to do when I was a biomed in the military. Oh, Jesus, you could be asked to do anything. We would have squirt guns, and we would go out and we'd shoot down the condenser coils of the air conditioning units in the desert. You would go out there. It was your detail. It was your duty to go out and shoot down periodically the coils on the air conditioners just so that they could operate within tolerance. I mean, as biomeds, there's so much stuff that we'd have to do. I want to do a video, by the way, about refrigeration systems and about HVAC. I know a lot of biomeds are probably saying, yeah, we don't need to know that. Yes, you do. You're going to use it if you're going to work on freezers, refrigerators, air conditioning systems. Hell, I mean, I've been in places where like there's too much humidity in the room, so you have to go and take a look at. You have to at least be knowledgeable of environmental controls. All right, it does happen. Bjorn and COVID. What's your thoughts about someone vaping beside you? Those fumes have been. Oh my gosh, you are. Oh, so honestly, I am very thankful that I was telling my wife about this. Guys, if there's one thing I'm absolutely certain of, it is that people in my generation and the generations younger than me are generally stepping away from things like smoking. Generally, okay? I understand in Europe that might be different, but over here, I'll tell you what, I hardly know anybody that smokes anymore, okay? Very, very few people I know that smoke still. And thankfully, I used to, and it's been well over a decade since I quit. And yeah, it's just one of those things. Generally, people are walking away from it. And vaping, I think over here in America, vaping was like a fad for a few years. And hopefully, thankfully, that's going away. Vaping is the only reason you can see it is because those are actual particles that, you're right, were in somebody's lungs. If somebody is vaping next to me, they're going to get punched in the fucking face. I'm sorry, guys. That just pisses me off so much, especially in this day and age with COVID. Those are literally vapor droplets that you are seeing. That is not smoke. That is vapor droplets that you are seeing. So vaping is, if somebody's doing that next to me, I'll be so upset, man, for sure. That is very interesting. You brought that up, Bjorn. I wonder what that's like over there. Did the hospital make you shovel snow? Oh, man, I'll tell you guys something. When I was in the military, I was attached to a Army unit my first 3.5 years in the military, and we did some crazy stuff. Now, I remember I worked at Landstuhl Hospital, which is a huge facility, right? And it snowed the night before, but we had a command sergeant major flying in. So they made us patrol around the hospital. They call it policing for trash. There was this much snow on the ground, okay? And if you guys don't know, a very large majority of trash is white. So you have snow on the ground, plus the trash is white. So we were walking around this hospital, and I brought it up to the E6, the sergeant that's in charge of us. I said, sir, let me just bring this up to you. We are walking around out here in the snow across these perfectly beautiful covered lawns looking for trash, but the only way we're going to find the trash is if we kick up the snow. And we got to get this done in the next couple hours because the command sergeant major's flying in. I said, does this not seem like a little bit of a conflict to you? And he gave me the story about some monkeys and something else. It's a good story, though. And when he was done with this story, I shut up, and we continued walking around the hospital looking for trash in the snow. So I've done some crazy stuff as a biomed, trust me.
From my understanding, a biomed isn't just someone who fixes medical equipment. It's someone that needs a general knowledge of HVAC and IT combined.
You are absolutely right. And it's more so now than ever. I have had to talk about HL7 and about drivers for medical devices with people that are definitely not computer people. But if you want to know why your device can't magically talk to the rest of the hospital, you have to know some of this stuff, okay? And if you're a Biomed 3 or if you're a senior level Biomed, by all means, you should have some sort of networking experience. Those days of not needing to know about computers are gone. They're gone, especially if you're a Biomed. They're so gone. I mean, you could be the most generic biomed working on infusion pumps, and you still have to have a computer in order to do the damn tests. So, yes, we need to know about everything. HVAC, I'll tell you right now. If you don't know at least the cycles of HVAC, I'll do a video on it. We'll go over that. You should know it because it's going to help you as a biomed to understand your refrigerators, your freezers, a lot. Okay. So I'll definitely maybe I'll do that one next. We'll figure it out. I don't know where to go from here. So
I don't smoke or vape. Vaping gives serious clouds.
And I was back when vaping first happened. I was very upset that I couldn't find good information. Believe it or not, that dog is not dying. She's done that her entire life. Hey, how you doing? So I thought. So vaping back when it first got started, it was such a propaganda festival online. Like I said, is vaping bad for you? And you could not find answers for that anywhere. I was going as far as 10 pages in on Google search, 10 pages in, and I still was not finding any sort of articles on vaping being bad. I mean, because if you guys don't know, vaping is glycerin. And what you're doing is you're atomizing glycerin, you're inhaling it, and you're exhaling it. And glycerin is not water. Okay, water in your lungs is not good. Okay, anybody should know that. I mean, hell, anybody that's ever had pneumonia knows that water in your lungs is not good. So magically, glycerin is. And if you guys watched in that video, I talk about the lungs and about the process of and how it doesn't exchange in your lungs with carbon dioxide. And you think that that can really happen when you're inhaling some sort of thick substance like glycerin? Anyway, that's enough of that.
From what I've been told, you'll hear over and over again, in biomed, you'll have to have a desire to keep learning.
Oh my gosh, you are not lying there. You know, it's very depressing when I go into work and I see items being put on the end of life list. I remember when that device came to the market. So learning, yes, it's constant. Hey, you got some water? No? You okay? Okay. That dog.
Happy New Year. Oh my gosh. Torquil, thank you for joining in, man.
Well, thanks for watching my videos. I appreciate that. Guys, I got so many cool videos that are going to happen.
Of a board inside a unit is obsolete. You can't find a replacement. Do you repair the board at component level, or is the whole unit considered non-repairable?
Well, I'll tell you what. In Canada, hey, Canada, I grew up in Michigan, and we go over to Canada because you could drink at a younger age. So I actually like that. Anyway, that's a good question, man. Depends on your hospital. It depends on your national laws. I mean, some of my viewers are in the middle of nowhere, and some of them are for nations that are still up and coming. And if you're in those environments, you are not going to get fined if you repair the board. In America, we love lawsuits, and that's up to you as a technician. I mean, how much risk you're going to put on yourself and on your hospital. If it's end of life, and your hospital has the budget, you are going to have to confront your director with your users about replacement. Because if it happens to one, there's a very good chance it's going to happen to others. So if you see a motor fail, if you see something starting to not pass electrical safety, if you see power supplies starting to fail, I'm telling you, if it happens to one, it's going to happen to another. So I normally, if it happens to one of them, I present them with the end of life letter, and I start warning them about, you know, how many of these items are in the fleet. Okay. And I should definitely do another video about this, because interacting with your customers and what reports you should give to them and whatnot is part of that. So if you have an item that's expiring, do what you can. What I'll often do, especially if I know they're still going to use some of these units, is I will save a unit. And if you have the real estate to do that, which this hospital does have some storage space, I will save some components like a power supply. If that unit, if let's say a user smashes the screen or something, I can't buy the screen, but I know the power supply is still good. And I know that the input panel, the I/O board on the front, I know that's still good. So I might salvage those, put them in a box, label the box, stick it on a shelf that, hey, you know, these are plasma ESU parts, and salvage some parts. Just label the box and make sure that the components you're putting in the box are good. Okay. But as far as like repairing the board at a board level, I've repaired some boards for like surgical tables, because they'll pop a little pico fuse. Pico fuse is a tiny little fuse that is designed to pop, and it's designed to pop if there's any sort of irregularity. I've showed other people, I think I don't know if I did a video on it, on how to repair some of those surgical table boards in case like your hand controller ever shorts out, you know, somebody smashes it or something. Well, guess what? Inside the table base, it pops a tiny little fuse that shuts it down, and we can fix that. I've done that before. So it's up to you. Now, if it's a ventilator, a anesthesia machine, or something like that, no, I'm not gonna goof around with that. This board kind of makes me think of that. I wonder if this is an anesthesia board. Now that I think about it, this might be a power supply for an anesthesia machine. That would explain what I'm seeing over here with all the different power outputs. But anyway, that's up to you and your hospital and your local regulations. I think a modern biomed must be some sort of MacGyver. We're expected to be a modern MacGyver. Whether or not you are, you're still expected to. So, yeah, that's true. Oil inside your lungs can be healthy. Oh, Jesus Christ. No, probably not. I'm choosing Biomed over HVAC because I think Biomed is more stable year-long job as opposed to HVAC. Well, depends on where you live, man. Because remember one thing, HVAC is a cheaper school generally, and if you want to develop your own business, HVAC is obviously where it's at. It's up to you and your hustle. So if you're not one to hustle, I'm not saying like abuse that, but if you're like a real go-getter, you can make some money. I know some people that are making well over 6 figures doing HVAC. Okay. It's just up to how motivated are you, how many hours are you willing to work, are you willing to be on call, stuff like that. So that's a good one, man. It's up to you. Biomed's a very cool job. You definitely see some satisfaction for what you're doing. You don't feel like you're screwing people over all the time. It's all up to you. I can tell both would be kind of satisfying. I don't have to normally crawl into 120 some degree attics. But I know a bunch of HVAC guys that come out from under houses and stuff, and they're all sweaty and dirty and stuff. That happens very rarely in Biomed. All right. So I work in an air-conditioned environment, stable job, in a hospital, which if you're single, there are lots of ladies walking around hospitals. I mean, it's up to you. Hi. Side to the doggo.
Oh, well, if you can't tell, my kids were playing with the dogs earlier, and they're just chilling over there. So, if you guys can't tell, this is as live as stuff gets, man. There is nothing scripted here, and that's why stuff like that happens. It is what it is, guys. Well, I will tell you all what. I am already starting to get some crazy ideas for some new videos, and I'm gonna go and write some of those scripts right now, I think. So I want to take this opportunity to thank you guys for watching this. This is a 3-hour stream. Jeez, you guys are so crazy. Do you think civilian BMETs are less skilled than military BMETs? Ooh, that's a good one. I'll tell you right now, if you are a military trained biomed and you apply for a job, you have a significant chance of getting that job. You either do it because of camaraderie. A lot of biomed managers are prior military, a lot of them, in fact, and they know the training that you went through to be that military biomed. But then again, I know some guys that are just crazy smart as civilian biomeds. So that's really kind of a tough thing, man. I will tell you for a fact that the biomed school in the military is, if not the best, it's one of the absolute best biomed schools in the world. So, I mean, it is what it is. I mean, 90% of the biomeds I've seen are retired. Yes, guaranteed, man. Guaranteed. And I just happen to be part of that club. It was just fortuitous, man. It's, you know, here's the one thing, and this is going to be probably the only time you hear me say this, all right? There's one absolute difference that I found between military biomeds and non-military biomeds, okay? So here's the absolute difference. I have been sitting there working on a device or working on a room to get the room up and going, and I've had civilian biomeds there pitching and complaining next to me because, like, it's lunchtime, it's time to go to lunch, and I'm looking at them like they're crazy because every minute that a room is down, every minute is lost money, and it's somebody's grandmother, somebody's child is not able to get their surgery for the day, okay? And one of the things I'll tell you about military biomeds almost completely is that if you say, hey guys, I have this mission this weekend, I need 3 guys to come in and help me, we're going to get this done, okay? They will almost stand unilaterally. I mean, if I'm telling them to do it and I'm not going to be there, that's one thing. But I'll tell you, as a military team leader, if I tell one of my guys to come in this weekend for a special project, I'm going to be right there with him. If I tell him he's going to be cleaning toilets, guess what? I'm cleaning the toilet next to him. Guaranteed. But here's the difference. Military biomeds generally know the suck, okay? I wish I had my bag I take with me every day to work, because I've got it written on the outside of my bag. I'll show you guys some other time. But anyway, we know the suck, and the suck is it's going to be unpleasant. Whatever this task is, we just know that we got to get it done. All right. That means if you have to work through lunch, skip lunch. It happens. I'll skip lunch. Hell, I skip almost half my lunches. You know, if I get some sort of emergent call right before lunch, you think I'm going to sit there and Band-Aid fix it just so I can go back and eat some sandwich or something? Hell no. If anything, I'm going to skip my lunch for the day and I'm going to get it done. Military biomeds, I have generally never had a problem. If I say, like, let's come in this weekend and let's do a PM sweep or something, I get these guys lined up and they're ready to go. They're generally very punctual. If I say, like, we're going to start at 8 o'clock in the morning, hell, I'll tell you, I've told guys, like, hey, let's be here at 4 in the morning. They're there. They're there. So that is definitely one of the things that I can say about military biomeds. It's not necessarily about them doing the job better. It's the fact that they know about the suck and they will stand with you until the job's done. So that's just my opinion. That's what I've seen. Jennifer Vasquez, thank you for tuning in, man, from Florida. This is This is interesting. Thank you for tuning in, man. See, I even know where you're from. I know, despite the caffeine intake. Uh, Surprised that you were able to keep up. Well, I didn't even know you were tuned in. I wish it gave me like a list of everybody that's sitting here watching me. But yeah, if I went over stuff a little too fast, just let me know, man. I just do. Um, I I had almost 30 people watching this stream at one time. So hey, I have, even if I had 2 people watching me, I I actually am very humbled about all that. So even if it's 2, but because I'll tell you what happens is these streams get saved and I will get hundreds of views on them after the fact. So I'm impressed with even 2. When I start up a stream and I'm sitting here preparing, thinking about what I'm going to say and whatnot, I see like 1 or 2 people log in, and I'm like, oh wow, all right. So I do appreciate it, guys. Should you put your military background on a resume if you didn't do biomed? Absolutely, absolutely. I don't care if you did security forces and you were a and you did that as a military. You should absolutely have that on your resume. It's part of who you are as a person, and even if it is completely inapplicable for the position that you're applying for, you should absolutely put it on there because it gives you a little bit more about who you are. So I completely say yes. And if you guys are looking for a job, I'll tell you right now, I have done this, and I've told other people to do this, and it will help you out a lot, especially if places are trying to figure out who you are. You have your paper resume, okay? I want you also to go out and record an intro video on yourself, okay? It's free to start up a YouTube channel. I'm not saying go and do anything like I'm doing. You don't have to do that. Create a private channel. But I want you to create a private video that says something like, hi, my name's Justin Barber. I've been a biomed for 18 years. I've done surgical laboratories. I've worked with teams. I love developing people. And I'm looking really interested in the moving to the Florida area. So let me know if you guys have any job opportunities or if there's anything pending for the future. And I look forward to hearing from all of you. And just put something out there. Create a video bio. Make it short, make it sweet, maybe 5, maybe 10 minutes. I'd stay closer to 5 minutes. Just say who you are as a person, your experiences, your motivations and goals. Just create a small video, because when you apply for jobs and they say any additional comments at the bottom, you can post the link for your video in your job application so that they can see it. And guys, they will. People often will click on that and they'll take a look at it. So create a short little video showing who you are. And if anything, if you guys have some specialty knowledge on certain devices or something, please, I'm not saying this for me, I'm saying this for you and for the career field and everything. Create a small little video. And once you do this a little bit, you'll get a little more used to it. I mean, trust me, like I've said before, if you see some of my first videos, you'll see I didn't know what to say. I didn't know how to act in front of the camera. Please create a video where you are explaining what you're doing, why you are a subject matter expert on this device. And that will not only get you used to talking to somebody or a camera, it improves your communication skills, but it also shows your technical capabilities, okay? That's something that's so hard for people when we're trying to figure out candidates for a position. It's really hard to figure out, can this person communicate well? Are they very technical as a person? Are they trainable? If you can see what somebody does, like through just a couple short videos that are free to post on YouTube, guys, those are awesome. Absolute awesome. If I've seen a couple people do it, Mr. Biomed's tuned in over here. Guys, I'm telling you, check out Mr. Biomed's YouTube channel, because he actually does some very simple teardowns and he says, hey, this is what's wrong. And he's changing out the component and he puts it back together and it's working. Just simple little videos that shows, you know, what stuff you like to work on, your competency, and your ability to communicate. I mean, hell, it's going to take a little bit of time, but as I say on a lot of these videos, invest in yourself. Make yourself competitive. Guys, we are competing amongst each other. This is not a big career field. And we're competing against each other for these positions across the country. Make yourself stand out. Create a YouTube video that shows your intro. Post that bad boy when you are submitting an online application for these hospitals. Post the link for your video in there. They'll check it out. They often will. Oh, let's see. No public. Oh, you guys. Oh my gosh. Champagne. Oh, guys. I have some wine here, but I'm talking so much that I'm not even I'm not even paying attention to it. Very interesting chat, teachings and points of view. Bolivia, no kidding. See, I get some crazy locations on here. That's so awesome. Ramiro, thank you very much for tuning in, man. We all would love to find out like what it's like over there in Bolivia, man. I get some of the best viewers. I really do, man. Angela is over there in Bahamas. Yeah, see, I remember where a lot of you guys are at. Has LinkedIn provided you with a lot of networking opportunities? Yes. 200% yes. And it's funny because as I've developed as a professional, I have paid more attention to LinkedIn, not only for just your networking, but some people post excellent content on there. Okay. It's LinkedIn. If you think like MySpace and Facebook, and then you have LinkedIn, which is way up here, professional content, some really interesting stuff. Some people are getting to treat it more like Facebook, but there is some cool stuff on the future technology that people are posting on there. And I appreciate that. And if you guys make cool videos on your technical expertise, post them on LinkedIn, guys. I'm telling you, people watch that. I've got people from companies like Zeiss and some other companies that might, not be happy that I criticize their product, Novolo, but you can contact people that normally would not hear your opinion, and you can do that on LinkedIn. I've talked with CEOs, I've talked with investment bankers, I've talked with all sorts of people on LinkedIn, and it's awesome. I've talked with neurosurgeons on there, cardiologists. There's some really good content on LinkedIn, not just networking, but also stuff to develop you as a person. But as far as people, yes, I reach out to people on LinkedIn daily. Okay, I pay more attention to LinkedIn than Facebook or any of that other stuff, man, because it's cool, and there's people with some really cool stories on there. So, guys, if you don't have a LinkedIn account, get one, and you can post content on there. I was telling about YouTube. You create a YouTube video, you copy the link, and you go into your profile on LinkedIn, and there's a little plus, and it says link. You paste your link in there, and then you type in a short little description on it. That's how some of you guys probably found me on here. I understand that. Use LinkedIn. On there, there's people that are potential employers, and there's potential colleagues. And if you are good at what you do, or you really love what you do, create a small video on it, on all this cool stuff that we see every day, and post it on LinkedIn into your profile so people can see who you are as a technician. Because it's so hard figuring out what type of tech somebody is. We have all had that guy that walked in, talked a bunch of talk, and come to find out, oh my God, this guy's a horrible technician. We have all done that. It's every single employer's worst nightmare is that technician that's going to come in and just be a drag. All right. But if you're a positive person and you know how to communicate, you love what you do, you're trainable, you show that you're learning all this new stuff, whatever it is, I'll tell you what, man, I have people that go through my LinkedIn all the time. They're looking at my profile constantly. I see all that. And the thing is, it works. It really does work, guys. Use LinkedIn, please. And it's for the better of all of us that everybody starts using it. Hello, I really enjoy your videos. Ryan, thanks, man. I graduated from Biomed program about a year ago and was wondering your take on new biomeds and finding a job. Well, I covered that a little bit earlier in this stream, it just so happens. That is, it's a very interesting time right now. Ryan, if you can't tell, I'm telling you the formula. If you watch this stream later, I'm telling you the formula for making it successful. You are a product. You're not just a technician, you're a product, okay? And you got to sell it. You got to sell you as a technician, which means you got to be better as a product. You have to be better at what you do, and you have to be able to prove it. One of the ways to prove it is to get certifications. One of the ways to prove it is to do videos, even small little excerpts. If you do staff trainings like in-services or something, just record the in-service. Just have somebody stand back with a phone recording the in-service and showing what you do. And then save that bad boy and post it to your LinkedIn profile. I'm telling you, it helps. I have been there when we're looking through a stack of candidates and we're trying to figure out who these people are. And so many people have the same stupid crap written on their resumes. That's why I made the resume video, because there's some annoying stuff that people keep, like the fluff at the beginning of their resume. Oh, just don't give me fluff. As soon as I start reading fluff, I'm like, oh gosh, Jesus Christ, just show it off. Same thing with LinkedIn profile. How many people have that copy and pasted LinkedIn profile? I can almost recite it from scratch. Experienced technician, is skilled at troubleshooting, yada, yada. It's like, oh my gosh, please do not put that in there. For your LinkedIn profile, just write like, make it personal, okay? Don't write in the third person on your profile on LinkedIn, okay? There is not some magical person that's a publicist or something writing about you, right? You are writing about you, and you want it to be personal when it's your LinkedIn profile. So put it in there like, hi everyone, I've been a biomed for 18 years. I've worked on this, 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 and this. Make it personal. Say the word I. It's okay. And tell us about who you are. Don't add fluff like experienced technician. How the hell do I know if you're an experienced technician? All right. I know how I know. I'll go through your profile and I'll look. And if you have like videos showing you giving in-services to nursing students or something, then yes, I know that you know what you're talking about. If you got certifications and you post them in your LinkedIn profile, I'll see it there. Okay. But the fluff, oh my God, the fluff is just driving me crazy, guys. If you don't know, COVID regarding, I meant 160,000 infected all over the country wide. Is there much SMD components and medical boards you repair? Well, the general consensus is many places would prefer us here in America to go around and do something called PM work orders instead of repair work orders. It is the general trend, and I do not support it, okay? Because that means that we become the middleman to shipping stuff out to the manufacturer. That's how it is in America. In other countries, you might repair stuff. SMDs, like this little guy right here, I went over that earlier in the stream. That is a little MOSFET that was on a charging circuit for a rapid infuser. Well, I've got a couple of them on there because I've had a couple of them go bad. SMD level repairs is becoming extremely rare. And it's a shame because we can save money and we can do the job good if we're allowed to develop these skills. But often we are not allowed to because they want you out there doing PMs. And I'm going to say this on camera in front of everybody. A vast majority of PM work orders are complete bullshit. Okay? I'm telling you, and some of you guys might be like, oh my gosh, you insult, just like anybody that ever says anything against like CBET certification. Oh my God, I'm going to be shunned by the entire biomed community because I am not like out there charging with the torch saying everybody needs a CBET. That's horseshit. Well, the thing is like a vast majority of PMs are garbage, okay? But then there are some PMs that are absolutely necessary, which is why me and my current employer haven't always seen eye to eye, all right? because there's certain shit that likes to catch fire when it gets hot. And just because there's nothing to calibrate it on doesn't mean that we don't vacuum out light sources or blanket warming cabinets. You know, that stuff collects dust, okay? And it has a heating element. And either it's going to break more often because it hasn't been cleaned, or it's going to catch fire, you know, because things with heating elements do that. But me and my employer, we don't see eye to eye on everything, because it's more important to go out and just pound cement and do a bunch of PMs that don't necessarily matter. And you guys know what I'm talking about, because you guys have probably been doing it too. If you can't tell, there's certain stuff that it just gets me. Hey Justin, do you think it's a good idea to buy some basic tools before job hunting? I was going to buy all the tools from 90% Tool Bag Video. You know something? When you start a job at a hospital, even me as a senior technician, when I start a job at a hospital, a very large percentage of those hospitals are going to give me just some garbage bag of garbage tools. Now, if you can't tell, I am a specialist. It's what I do. I can do stuff that some other people can't. And I like having special tools to allow me to get the job done when I need to get it done. Okay? Every hospital has like the specialist, people that can do stuff, you know, can make things happen. And I do a lot of that stuff. And I like having my specialty tools. And it could be something as simple as this. This is not a standard item for most biomeds. Almost nobody has these. Do I think people should have them? Absolutely. You know how many times I've seen biomeds putting their hands in something that's still plugged in or it's still hot? Whereas all they got to do is turn this guy on, wave it around. Okay, it's off. You know, we're good. Now we can work on it. But I'm telling you, there's so many things. What about even something as simple as eye protection? I'm telling you for a fact, there are so many hospitals that don't even supply their biomeds with eye protection. I have 1 or 2 sets of eye protection in my tool bag at all times. Yes, you look like a nerd when you're wearing it, but when you go above ceiling or you're under a surgical table looking up and some goo juice is dripping down, do you really want that crap in your eyes? I mean, seriously, there's so many specialty tools, and it doesn't have to be anything special. It could be something as simple as a $3 set of eye protection. And it's just, if it's not standard issue, then, you know, hospitals are reluctant to give it out to their technicians. So if you like certain tools, I highly suggest you go out and buy them. I highly suggest you engrave them. Engrave your initials, like JB. I engrave on my tools, because stuff happens, man. All right. So engrave your tools if you're going to buy your own private tools. Let's see what DJ says. Hi, I'm DJ. I was a terrible student, did my internship, and it turns out I was learning something this whole time because they're always running stuff out for me to do. Yep. Indirect learning. Mr. Ken, thank you for tuning in. There's certain things that I'm very passionate about, and one of the things I'm passionate about is I honestly think that more biomed shops should have somebody that is responsible for inspecting the biomed program internally. Kind of like your ISO certification, you have to have somebody internally audit. I think that there should be a senior level biomed that goes around and checks the other biomeds to make sure that their work is up to par, that they're documenting stuff correctly, and that they're inspectable at all times. I understand manpower doesn't always allow that to happen, but I do think it's the direction that we should be moving, instead of having people out pounding cement, looking for thermometers and other garbage that really doesn't matter. There's so much stuff that we do not do, okay? I had just a couple days ago, I had a handheld pupilometer, okay? Now, this is going to be arguable, all right? A pupilometer is a device, it's battery powered, it's a class 1 device because it's got a weighted base that sits someplace else, and it charges the pupilometer when it's docked. And when you go to use it on a patient, you have to remove it from the base, and it's battery powered. Okay, so battery powered devices, that are not allowed to be plugged in while they're used on a patient are class 1 devices. Class 1 devices are the lowest, they have the lowest regulations surrounding their electrical. So this pupillometer, it's a class 1 device. I go in and I ask my boss because I honestly want his professional opinion on this. He's the boss. I say, hey, I've got a class 1 device here. It's a pupillometer. Should I put this on record? And all you guys know why I'm hesitant on putting these 4 pupillometers on record. It's a battery-powered device. It's about yay big. It measures the diameter of the pupil, okay? That's all it does. I'm never going to see this device again, okay? I'm going to give it to the customer after I checked it in, I added it to record, and I am never going to see this device again. So if I ever have to find it for a PM or something, I'm never going to find it again. It's going to be in a drawer. It's going to be lost. It's going to be dropped and broken. It's going to be stolen. I'm dead serious. Like, I'm never going to see these things ever again. And I know that. So I at least asked the boss, hey, do you want me to put these on record? And he's like, they're used for treating the patient, right? I said, yeah. And he's like, but they measure something, right? And I said, yeah. He's like, well, of course you're going to put it on record. I'm like, okay. All right. You say so. I mean, that's why I asked. It's not rhetorical. I really wanted an answer. But I mean, I know and he knows I'm never going to see it again. But I mean, when I say I work at a large facility, it's large, okay? I'm never going to see those devices again. All right. Thank you a lot for the information. One more question about the certification. Besides CBET, that is an excellent question. Guys, I would highly suggest getting A+ certified, especially if you are a younger biomed and you are fairly technical. Get A+ certified. It's an easy test. It's actually 2 tests. It's an easy test, okay? You can study for it. There's an abundance of material out there. There's flashcards. There's websites that you can log in and they can help you. I'm telling you, there is so much information for A+. It will help you with your job. It's going to help you get jobs because it's certification. As I said earlier, compared to CBET, there's certain things that can help you get certain pay grades better than CBET. A+ is one of them because you can move into that medical networking type position if you have your A+, okay? If you don't have your A+, good luck getting that job. Just saying. It would be helpful if you make a video about how to check all the components using CRO. What is CRO? I'm honestly asking because different countries have different terminology for this, and I'm trying to think CRO, and I don't know if it's because I'm tired or what. So I'm trying to figure out what it is right now. How necessary are isolation transformers in your line of work? I mean, as a technician, not as an operator or final client. Well, understanding isolation transformers, absolutely, especially if you're going to be working in operating rooms. You should know what it is and what measurements to expect. If you are going to fix things like power supplies on your desk, especially power supplies for things like light sources, because yeah, maybe I'll do a video on how I think I did, about how a xenon light source power supply works, how it's a high voltage arc, and then after that it's a high amperage low DC that keeps it going after the initial arc. So understanding the high voltage in that bad boy and having an isolation transformer while you're working on it is probably going to save you, man. You should at least understand what it is. And Ramiro, as you said, right there, that's actually a fantastic point. I said on that isolation transformer right there, that power strip that's plugged into it, the ground is not connected. Why? Because what you just said. I can plug a standard benchtop like Tektronix oscilloscope in there, and I don't have to worry about shorting out the ground. Because if you guys don't know, on the outer edge of your B and C connectors, like this guy right here, this is a miniature one. Obviously, this one is not grounded, but in almost every single benchtop oscilloscope, the metal outer edge of your B and C connector is directly connected to earth ground. So if you are just goofing around and you're playing with these leads and you get them on the wrong phase or something else, you are going to put your oscilloscope up in smoke. So a lot of times what people do is they float the ground, which means you break off the ground connector on your oscilloscope cord, or I have ground just floated inside the power strip. It's not connected to anything. So I can plug into that, no problem. That power strip will be on my electronics workbench, and I can plug my oscilloscope in there, and I don't have to worry about it. You never know. Like one day you're going to reference on some board like this guy. If you reference, I mean, could you imagine? Like this down here is all the AC. If I reference on the wrong part on this, I would explode in the oscilloscope. So float that ground. Yes. Cathode ray oscilloscopes. Oh, okay. Oh, you know something? I do not have a cathode ray oscilloscope. I've had them. I mean, I've had a bunch of them, but it's just the portability and the beautifulness of those, the ability to record a waveform over a period of time, and the sample count that we have on these new digital oscilloscopes is so nice. I mean, we don't use oscilloscopes too often, but if you're testing power supplies, you should get familiar with oscilloscopes. Absolutely. Because otherwise, I mean, how are you going to know? Because once it goes from DC back to AC, under this bad boy, once it goes from DC back to AC, where it's going to step it to your final output voltage, you have to know roundabout with an oscilloscope what you're looking at. So it's probably a good thing to know. If you connect an oscilloscope to an ungrounded power source, you have mains leakage through your X2 safety caps to your B and C. Well, I don't know about that. I don't know. I've honestly never had mains leakage that I know of. I mean, shit. I suppose it's possible. What's the difference between a regular oscilloscope? Well, a lot of people like the CRT scopes because of the trace or what you're looking at, and because the signal that you're seeing on the CRT is exactly what you're measuring. I mean, it's whereas with a digital one, the signal has to go into analog digital converter or something like that, and it has to go through a lot more shit in order to get on your display. And sometimes on the newer digital ones, with the older ones, all you had to do is adjust your time and your voltage, and bam, wah, magic. On the new ones, we have the auto button, which on a vast majority of your signals, you can just hit auto, and that pisses off a lot of old timers that we can do that. But if I got a multi-channel digital oscilloscope with colored traces and stuff, and I hit the auto button and boop, boop, it pops up two beautiful waveforms on there. I mean, haters gonna hate, I guess. Let's see what else we got. Well, yes, it can definitely give you false results. I honestly, I've never seen that really matter on a lot of the stuff that I test, but I suppose it definitely could. Yeah, that's right. That's right. When you float it like that, it's not at 0 volt potential anymore. But that's also why I have switched to, the digital portable oscilloscopes. I mean, they're just so nice. If you see like those, what is it, the 199C Flukes, very nice oscilloscopes. And for most anything I'm going to do, they're perfect. What about using differential probes with proper attenuation instead of floating the ground? Oh, well, yeah, you could. I don't know about you guys in your shops, but usually you are fighting just to get good probes and attenuation, and man. See, now you're going a little deep into it there, Bjorn. I'm reading your comments there. Yes, you are absolutely right. For these type of things here, it's not really going to matter. If you float your ground, you're testing power supplies, you should be all right. I can't say that for this guy. Obviously, this one has got a microcontroller that is manipulating all those output fields. That guy there, I cannot say that for. Most of these guys are really simple. They have the optocoupler, which is your feedback loop, and it's actually very simple. In fact, a very, very large majority of stuff I do with this multimeter right here, and it's very quick. I mean, like I said, for these guys, capacitors, you're from there you're going to go to your MOSFETs and your diodes. Find your short if you have a short, and usually there's some discoloration that's going to help you out. I just noticed on this board that a couple of my ICs got a little hot. You can see it right there. It's discolored the board. Big help. Oh, very cool, guys. Like I was saying, I don't know if I can see this. You can see how shiny the board is on the bottom of this. What's really odd, the top side of this is not conformally coated, but look at the bottom of this. As we talked earlier in the video, even my ICs, you can tell, have a conformal coating on them. You see how they're shiny? I didn't even look at the bottom of the board. That's very cool. So the back side of this board is conformally coated. The top is not. So if I wanted to read the values on these chips, I have to actually scratch it off in order to read it. I wonder why I didn't even think about that. Oh my gosh. Is there anything else I can answer for you guys? It was my pleasure. And this is my longest stream yet. 3 hours and 40 minutes. This is absolutely insane. In so many ways, I hope that some of you guys didn't listen the entire 3.5 hours. That's a long period of time. My voice feels a little hoarse as well. Previously, you spoke about Arduino. Have you ever found Arduino development related in medical equipment? Yes. Yes. That is actually a very good question. Okay. So how about this? I was see, that's why it's nice to study up on this stuff that's outside of your biomed scope, because you never know when this is going to walk into your life and you have to know something about it. I did have to know about that because they had door sensors. And what they were doing is they're doing a study on how many times somebody comes and goes from their orthopedic surgical room and whether or not that affected the trend of infection rates. So what they had is they had Hall effect sensors, which are magnetic sensors. They had those on top of the door, and it would detect every time the door would close, right? And it had an Arduino that was keeping track and controlling some of that, okay? Well, since I knew about Arduino and I knew a little bit about what they were doing, I was able to help them out when their people, after they started the study, they went like back to Stanford University, and they called me up and they're like, "Hey, can you go over and can you check out our setup?" it's, you know, it's not replying back to us, and we haven't gotten any data coming in. And because I was familiar with what Arduino was and about all the different components that connect into it, I was able to help them out over the phone. They just told me what to expect, and I just was able to go and tamper with it in between cases. You never know, man. You never know. That's why I say study up on everything you can. And as soon as you find out something cool like that you didn't know, go back to your desk and do some research. What do you think about the CABT? What is the CABT? Can you help me out with that? What is that? Is that new Certified Associates of Biomedical Technology? Is that what that stands for? Is that the associates that they came out with? My last stream, I went into some detail on that because it's, I don't know. I say if you want to go for it, man, like I said, anything that will set you out from somebody else, go for it. Go ahead. But they advertise it. Maybe that's why. It's because Amy themselves advertised it as get your certification before you even set foot in the door of the hospital. And it's like, don't say those words, because everybody that's ever been a biomed knows, like, every time you go to a new hospital, your learning curve is like that. So basically, by you getting that certification, you're saying, I don't know shit, but I'm certified. Because none of us know shit when we go into our first hospital. None of us. Not you, not me, no, none of us. And I was, what, 9.5 years of military biomed before I went to my first civilian hospital. The day I walked into that first civilian hospital, I was like deer in the headlights. Crazy different world. And many times I've gone into other hospitals. When I've started new jobs and stuff, every time you go to a new hospital, it's deer in the headlights. They've got different terminologies, different culture, different rules. They even call different things. Somebody might call it a pre-op. Somebody might call it like a holding. I mean, the culture between hospitals just drives us crazy. But I have to learn every time I go into a new facility. The place I'm at, you got so many different places. They call. Well, I don't know if I can give the name. Somebody that has a cardiovascular OR would normally call it a CVOR, cardiovascular operating room. These guys call it something else, and it drives me crazy. So when I say like CVOR 3 or CVOR 2, well, believe it or not, anybody that's been a biomed at any other hospital in the world would know that a CVOR is cardiovascular operating room. But these guys don't know it because it's not their name that they call it. Okay? Drove me crazy when I started working here. And to this day, I still call them cardiovascular OR1, cardiovascular OR2, etc. They call it something else. And I can't tell you what it is because that would be a dead giveaway to where I currently work. And I'm like walking on eggshells where I currently work anyway, because we're not allowed to record video in there and stuff. And, you know, it is what it is, man. But guys, oh my gosh. I think right about there is where I'm going to cut it, because I have so much other stuff that's still in my head that I want to write down before I can go to bed tonight. And I have no idea what time it is at all, actually. Oh, Jesus, criminy. It's 11:40. Guys, thank you so much for watching. And think about it. If you have some really interesting stuff that you are going to ask, I'm going to do these live streams once or twice a week. Feel free to write down what you want to ask. And as you can see, this is one of the most successful chats we've had, because there are so many subject matter experts out there, and you guys are what make this. I'm learning from you guys, man. I'm just up here talking because, shit, it's 11 o'clock at night and I have no life. But all I'm saying is, like, guys, there are so many people here that know answers. So if you can think about it, next time I have one of these live streams, tune in and ask your question, because I guarantee some of us are going to be able to help you out, okay? That is so awesome. Bjorn, it's 7 a.m. Go eat breakfast, man. I got to get some sleep, but you go eat your breakfast. The engineering high. Man, guys, I have so much cool stuff that I want to talk with you guys about. And, you know, at some time, like I have to like hold back because I don't want to appear like I'm too much of a nerd. but truly I am. And, you know, I take pride in that. So thank you guys for sitting here and being on this journey with me. Go get your breakfast, Bjorn. And you guys, especially you Islanders, you guys go and enjoy your beautiful, beautiful day. And shoot, I think I'm going to have to go and write this stuff down before I forget. So thank you all for watching. And stay tuned, man, because I think that this one went better than any of my others before. And this is so awesome that you guys are tuning in and chatting amongst each other, which I really like to see because, as you can tell, we have some crazy, crazy viewers from all around the world, and we all have some similarities and some major differences. And I love reading about this stuff, guys. So thank you all. Have a good night or a good morning, and stay tuned. All right. Thanks for watching, guys.